Welcome and thank you for standing by. Today's session is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn the call over to your host, Lin Wang from the U.S. Census Bureau. Lin, you may begin.
Good morning, everyone. For the 2024 FedCasic. My name is Lin Wang, and I'm the chair of the 2024 Organizing Committee. Some of you may know, in the past 3 years, I have been running this event every year and missed the fun of presenting my own work. So today, I decided to steal a few seconds to show off my analytic talents. Okay, here's what I did last night. Sorry, I have to redo it somehow. Okay, that's the correct one. I'm sorry. All right. What you're seeing is a graph called stack bar chart, and the data is labeled administrative that were collected by the FedCasic Organizing Committee. I applied the most advanced analytical method as I know of for the tabulation to the data. And the results show the distribution of FedCasic session topics over 4 conferences, starting from the first virtual conference in 2021. I personally observed 2 things significant here. One is an increase in data science application over these years, with the color coded in dark blue at the bottom. The second thing is the session topics cover almost all aspects of technological advances in survey operation, from data collection to data dissemination. As a scientist, we are required to complete a study with an interpretation of our data. So here's my interpretation. FedCasic workshops provide a setting for government survey researchers, practitioners, and contractors working on their surveys to meet and exchange information on all aspects of technology and methodology pertinent to design, management, and operations associated with survey data collection. This is the mission of FedCasic set forth in its recent crafted bylaws, and we are proud of ourselves in fulfilling this mission. Further, the mission is being fulfilled by this amazing team of volunteers and you of all attendees, presenters, moderators, and last but not least, our WebEx support team. So please give them and yourself a round of applause. Now, it's my great pleasure and honor to introduce our keynote speaker, Professor Joseph Saxall. Dr. Saxall is a social statistician and survey methodologist with over 20 years of experiences studying the quality of survey and non-survey data sources and the integration of these 2 types of data. His methodological interests including combining multiple data sources, handling missing data sources, the data issues, and addressing the effects of a non-response and a measurement error in surveys. Dr. Saxall is a distinguished researcher at the Institute of Employment Research and the University Professor of Statistics at the Ludwig Maximilians University in Munich. Today, he will give us a comprehensive study about data integration. Without further ado, please join me welcome Dr. Saxon.
Thank you, Lynn, for the nice introduction, and thank you all for attending. It's my great honor to give the keynote, one of the keynote presentations for the Fed CASIC conference. And as Lynn said, I'll be talking about data integration in survey research. Looking at possible approaches to addressing some of the challenges and opportunities in data integration. So as we've all seen or witnessed over the last decades, there's been a growing interest in integrating surveys with alternative data sources, not just administrative data, but also commercial data, social media data, digital trace data, sensor data, among others. And the way I like to see the way I like to describe data integration is where we use the strengths of one data source to offset limitations or weaknesses of other data sources. And there are many purposes or uses of data integration that I've observed in my own work, including methodological uses, such as using alternative data sources to assist with stratification, responsive survey design, investigating and correcting for non-response error, which I'll talk a little bit more later on in the talk, as well as studying and correcting for measurement errors. Of course, there's also other substantive purposes of data integration. We can link survey data to administrative data or other types of data to enhance substantive research capabilities and address complex research questions that may be difficult or impossible to answer using a single data source. Another advantage of data integration is also the potential to reduce costs and increase efficiencies, both field work efficiencies and estimation efficiencies. And I will talk a little bit about reducing costs and increasing efficiencies later. But first, before I get in to some of the research projects that I've been working on, I wanted to bring a couple of special issues to your attention. These are two recently published special issues that I was honored to be a part of as a co-editor. Both in POQ and the Journal of Survey Statistics and Methodology, there were special issues carried out on recent advances in data integration, as well as augmenting surveys with paradata, administrative data, and contextual data. So I would encourage everyone, if you haven't already, if you're interested in looking at some recent work in data integration, to consult these special issues. I just want to advertise a little bit some of the topics that were covered in these special issues. These are just overviews of topics. These are not the titles of the articles themselves. But if these topics pique your interest, I would encourage you to have a look at them. So the JSAM special issue covered topics like presenting multiple data linkage consent requests in online surveys, linking survey data with mobile sensor data and its effect on panel retention. And then there were a few technical articles looking at the data cleaning pipeline and entity resolution correcting for linkage biases. There were also some very interesting applications of data integration, linking the WIC administrative records with the American Community Survey, and methods of linking vaccination data from the CDC with interdecennial population data to produce national and state level estimates of vaccination rates, as well as combining labor force data with labor force survey data with other alternative survey data to improve the precision of estimates. Looking at the POQ special issue, there were topics that were published on linking interviewer evaluations of respondents' performance to study respondent behaviors and response quality, as well as using client-side paradata to examine the issue of respondents looking up answers to political knowledge questions in web surveys. And there were other topics covered, including leveraging linked administrative data to examine misreporting, so measurement error in benefits programs and earnings questions, as well as evaluating non-ignorable selection bias in pre-election polling estimates using aggregate data. Further topics covered in the POQ special issue were investigating attitudes towards privacy in relation to the collection of mouse tracking paradata. And myself and Bella Struminskaya wrote an article on research ethics and challenges of augmenting surveys with alternative data sources. So that's just to give you a flavor of some of the topics that were recently published. For the remainder of this talk, I'll mainly be focusing on my own work and the most recent work I've carried out with colleagues and students. And I'll be particularly focusing on some selected aims and challenges of data integration, including linkage consents, ensuring informed consent, maximizing consent rates, using data integration to improve survey representativeness, mainly looking at non-response bias and enhancing non-response bias adjustments, as well as increasing estimation efficiency and achieving cost savings by supplementing probability sample surveys with non-probability sample information. So first, I'll be covering some of the work that I've been carrying out on linkage consent in terms of methods to ensure informed consent and maximize consent rates. I think everyone is familiar with informed consent, and prior to data linkage or data integration, respondent consent is usually required. In some countries, this is law, including Germany, where I carry out a lot of my research. And the purpose of this consent process is to ensure respondents are informed about the types of data sources that will be linked, the intended uses of the linked data, possible benefits and risks of the integration, the responsibility of ensuring data confidentiality, as well as the voluntary nature of the request. And we can see that linkage consent rates vary quite a lot from study to study. There have been a couple of literature reviews that myself and others have carried out looking at the range of consent rates across different studies. There was even some evidence that consent rates to linkage were decreasing in the US in some of the large-scale government-sponsored surveys. Although I'm not sure if this is the case anymore. I know there was a lot of revamping that was done in the linkage consent procedures for some of these surveys, and so these consent rates may not be accurate anymore. But the main concern is of non-consent error. The lack of linkage consent can reduce analytic sample sizes and increase variance estimates. And respondents who consent to data linkage may be systematically different from those who don't, and this could potentially lead to bias. And there's a number of studies that have looked at correlates of linkage consent, and indeed they find that linkage consent is correlated with many respondent characteristics, demographic, as well as more substantive characteristics of respondents, as well as interviewer-respondent interaction. Here is just a conceptual way of thinking about the pathway to linkage consent, where every survey will start with a sampling frame and draw a sample of units from that frame. Those units will then be divided into the responders and the non-responders. And only the responders are the ones that we typically ask for linkage consent from, and only a subset of those respondents will actually provide consent. And those who provide consent will then be linked. And some of those may be linked and others may not be due to faulty identifiers or coverage gaps in the linked data source. And so when we talking about linkage consent rates, we're mainly focusing on the proportion of consenters among those respondents who consented, and consent bias, we're looking at differences between consenters and the non-consenters. There has been some work looking at estimates of consent bias in surveys, including the Consumer Expenditure Quality Interview Survey, where they do find some significant differences between the consenters and the full respondent pool. So it does appear that that linkage consent bias can manifest for some types of variables. Here's a study that I was involved in where we looked at consent bias in administrative in linked administrative data. This was a special study where we had administrative data for the full sample of units that were surveyed. And we could look at things like non-response bias, measurement error bias, as well as linkage consent bias. And in order to estimate linkage consent bias, what we did was we linked the consent indicator to the administrative database. So even for those who didn't consent to linkage, we still had information from the administrative data about their characteristics, so that we could compare the consenters from the non-consenters to examine linkage consent bias. And this was useful in that we could compare linkage consent bias with more traditional sources of bias, such as non-response and measurement, for these selected characteristics. And what we found was that there were some significant linkage consent biases, but they were relatively small compared to measurement error bias and non-response bias. So this might suggest that if you have limited resources to address these three sources of bias, you may want to focus more of your resources in reducing non-response and measurement error bias, as linkage consent bias seems to be less of a concern. There's also been some work looking at methods of optimizing linkage consent rates in surveys. And these efforts have mainly focused on placement methods, where you would place the linkage consent question in the survey, as well as how you would word or frame or phrase the linkage consent question. And these are two methods that I will be focusing on now. There have been other methods that have been examined, including re-asking respondents for consent after they previously refused the consent request, as well as using active versus passive consent procedures. I won't talk about these last two methods, but if you're interested, happy if you drop me an email and I can refer you to some references on these topics. So focusing now on the placement of the consent question, Historically, linkage consent, the linkage consent question has been asked at the very end of the interview. And the conventional wisdom here is that at the end of the interview, this is when interviewer-respondent rapport is at its peak, and thus the respondent may be more trusting of the survey organization, the interviewer, and thus may be more likely to give consent to linkage. However, the relationship between rapport and linkage consent is mixed. And actually, the experimental evidence suggests that the end placement is suboptimal compared to other placements, including asking at the very beginning of the interview or asking in the context of other topic-related items. So just to show you some experimental evidence from work that I've carried out. This was an experiment in Germany. There was a telephone survey carried out with 2,400 respondents, and the linkage consent question was randomly placed at the very beginning or at the very end of the questionnaire. And indeed, we found that the consent rate was marginally higher, modestly higher, when consent was asked at the very beginning or close to the beginning versus at the end. This experiment was also replicated in an establishment survey, a business survey in Germany, where again we found that asking for consent at the very beginning leads to higher consent rates versus the asking at the middle or at the end of the survey. Looking at the wording of the consent question, here is where surveys have some flexibility in how they phrase or how they frame the consent question. There might be some legal wording that is required to be there, but there is some leeway in terms of how you script the remaining parts of the consent question. And often linkage consent questions emphasize the benefits of linkage, such as it saves time or it reduces costs, it reduces burden, it improves data accuracy. I've also seen some surveys that actually shorten the survey, shorten the questionnaire if the respondent gives consent to linkage, then they don't have to ask as many or don't have to answer as many questions. However, the empirical support for this strategy, this benefit framing or gain framing strategy tends to be mixed across different studies. Some studies find no effect of benefit framing versus a neutral framing. There was one study that Frauke Kreuter and I were involved in where we found a positive effect of the time-saving argument in a web survey versus a neutral argument. And most recently, there's been some work done looking at the opposite of benefit framing or gain framing, which is loss framing. So instead of emphasizing the positive benefits of linkage, emphasize the negative consequences of not linking one's data. And this theory has some tenets in prospect theory by Kahneman and Tversky. And we carried out an experiment, testing, comparing a gain frame versus a loss frame to see if the loss frame might actually lead to higher consent rates in our study. So this would be an example of a gain frame. The information that you have provided so far would be a lot more valuable to us if we could link it to X, Y, and Z records. Versus the loss frame, where you would ask consent and emphasize that the information that you have provided so far in the survey would be much less valuable to us if we can't link it to administrative records. So here are the results from that experiment. Here we indeed found that respondents in the loss framing group were more likely to consent than those in the gain framing group. Now, bringing this all together, another study that was carried out by Frauke and myself, we looked at the interaction between placement and framing of the linkage consent. And this was carried out in two separate studies with the same questionnaires. One was carried out by telephone and the other by web. And so we can see here that in both of the studies, we see a placement effect. So those who received the consent question at the beginning of the survey consented at a higher rate than those who consented at the end. And this was consistent in both surveys. Looking at the gain-loss framing, we see that in the telephone survey that there was little difference between gain and loss framing, regardless of where the consent question was placed. However, in the web survey, we did find an interaction, especially when you ask for linkage consent at the very end of the survey. We see here that the loss framing yielded a higher consent rate than the gain framing, but really only when the consent question was placed at the very end of the survey versus at the beginning of the survey, where we didn't find a very meaningful difference between the two consent rates. We suspect that the reason that the gain-loss framing worked more effectively in the web survey is because this is a visual mode, and the framing may have become more salient in the visual mode versus in the telephone mode, where there could be some interviewer effects, or maybe the interviewer didn't emphasize the framing as much as they could have. But these are just speculations on why we suspect that there was a difference between the two surveys. Now, those were methods of optimizing consent rates. I want to spend a little bit of time looking at consent understanding. And when we talk about informed consent, we imply that respondents are well informed about the linkage process, and that they have all of the relevant information that they need to make an informed decision. But one question, or one open question, is how much of the linkage consent process is understood by respondents, and are less informed respondents less likely to consent than those who are more informed? And these are empirical questions that we attempted to answer. Here was a study carried out at the IAB, where we asked respondents questions, or knowledge questions, about the linkage process. And answers to these linkage questions were provided to the respondents before the test, before these questions were asked. So in theory, they were provided with all of the information that they needed to answer these questions correctly about the linkage process. And so here we looked at the percent of correct answers to questions like whether their survey answers would be sent to the IAB, whether their survey data would be merged with IAB administrative data, whether their personally identifiable information, name and address, would be saved, whether the results of the survey would be linked to them as a person, as well as access, who would have access to these data, and whether there any identifiable data would be publicly accessible. And so here we can see that for the consenters, for those who consented to the linkage, they answered the correctly at a much higher rate than those who did not consent to linkage. Yeah, the results were quite striking. I mean, especially, if you look at the answer to the question about whether their data would be merged, whether their survey data would be merged to administrative data, clearly that would not be the case for those who didn't consent to linkage. But there was still a very large, over half of the non-consenters still believed that their survey data would be linked to administrative records, even though they didn't consent to that linkage. So these results do suggest that there does seem to be a relationship between knowledge and consent. Perhaps if we as survey researchers do a better job of informing respondents, maybe we would see an uptick in these consent rates. But clearly that is a challenge to ensure all of the respondents are informed about the linkage process. So I want to move on next, looking at how data integration can be used to improve survey representativeness. And I'll mainly focus here on non-response bias evaluation and enhancing non-response bias adjustments. We all know that non-response poses risks to accuracy and survey inference and survey accuracy. And non-response is likely related to substantive phenomena, and including, well, when we conduct surveys with establishments, non-response patterns could be related to industry or the size of the establishment. For individuals and household surveys, a non-response may be related to employment status, whether or not somebody recently experienced a job change, or other life events that could affect their likelihood of participating in a survey. Now, in order to adjust or to correct for this potential bias, we often use auxiliary data or paradata that's available for the entire sample, including respondents and non-respondents. I'm mainly focusing here on sample-based adjustment methods rather than population-based adjustment methods, where you only need information about respondents as well as information about the broader population. But for sample-based adjustments, we're often limited to paradata or maybe some basic information from the sampling frame, possibly some demographic information or basic characteristics about businesses. But often this limited data is insufficient, I would say, for reducing for reducing non-response bias. However, alternative data sources like administrative data offers a viable source of auxiliary information. Often, at least with the administrative data that I work with in Europe, there's many variables that are correlated with the substantive variables of interest that we collect in our surveys. They may not be perfect correlates, but they're often highly correlated, especially in the employment databases that I work with. Often these employment administrative variables are highly correlated with employment outcomes that respondents report in our surveys. And so some of the recent work that I've been involved with incorporates administrative data into non-response adjustment methods. And I want to show you an example of this, focusing on the COVID-19 pandemic, where we saw an uptick in non-response bias in some of our surveys. So here's an example of the IEB job vacancy survey, which is the official job vacancy survey in Germany. This survey is carried out quarterly with a very large sample of establishments, and what we saw, because we had extensive administrative data that we could link to the sample, we could evaluate non-response bias in the survey for each quarter of data collection. And what we noticed in 2020 during the COVID pandemic, that the the non-response, the aggregate, the average absolute non-response bias increased significantly compared to previous quarters in previous for the same quarters in previous years. We saw quite a large uptick in COVID-19 related non-response bias. And the question that we wanted to answer is whether standard weighting adjustments are effective in reducing this source of non-response bias. And the job vacancy survey, the non-response bias adjustments is basically a standard propensity score estimation technique where logistic regression is used on the response outcome with only three covariates or three sets of covariates. We have information about industry and establishment size from the sampling frame, and we also have some pair data that was collected. But what we did here is we tried to expand or enhance the amount of covariate information available for our weighting adjustment method by including 16 administrative variables that we could link to the sample. And this was something that had never been done before in the job vacancy survey. The job vacancy survey has been in the field for over 20 years now, I think. Could be 30 years. And but all of this time, only a very basic set of auxiliary information that was used in the adjustment and in the non-response adjustment weighting approach. So we thought it would be worthwhile to see whether these additional administrative variables can reduce non-response bias to a greater extent than the standard weighting scheme. And so that's what we show. I'm showing you here now. So here we can see that. So we show here the unadjusted level of average absolute non-response bias versus the standard weighting approach using just the three covariates, and then the enhanced weighting scheme using the additional administrative variables. And what we can see that for before the COVID pandemic, the enhanced weighting scheme with the administrative variables didn't have much effect, didn't reduce non-response bias substantially compared to the standard weighting approach. So perhaps the standard weighting approach worked well, just as well for the previous years. But during the COVID year, 2020, we see that the administrative variables, by incorporating them into the weighting adjustment, we reduce non-response bias quite a lot compared to the unadjusted and the current weighting scheme. We still don't reduce non-response bias on average to a level that was comparable to the previous years, the previous quarters, to the same quarters in the previous years. But we do see that we were able to reduce that COVID-19 related non-response bias by a non-trivial amount. Given that we already had extensive administrative data, we can also get quite fancy with how we model the response outcome. And here we tried different machine learning methods to try to further enhance our weighting adjustments. If the response outcome has a nonlinear relationship that might include that might be explained by interactions or higher order terms in our model, perhaps we could reduce non-response bias even further. So we looked at a variety of different machine learning methods incorporating that we applied to the enhanced covariate information, but we didn't see too much benefits or reduction in non-response bias compared to the standard logistic regression modeling approach. So the biggest the biggest advantage that we saw was using the administrative data, but using the enhanced administrative data rather than the current just the three covariate the three variables as covariate information. But using the machine learning methods didn't have much added value compared to the standard logistic regression model, which was quite surprising to us. So from here, our main takeaway was it's more important to have good covariates in your weighting approach. This tends to have greater benefits than using more sophisticated modeling approaches like machine learning methods. However, this is just one data point, one survey, and we haven't replicated this with other surveys yet, but that would be interesting to see whether there might be some added value in other contexts by using machine learning methods in addition to administrative variables. The last topic I want to cover on data integration is this issue of increasing estimation efficiency and achieving cost savings. As survey researchers, we're always looking to cut costs, and that is true for the institution that I work for. We have a lot of pressures to reduce data collection costs and do more online data collection versus more traditional interviewer-led data collection. And so as we collect more online data, we're also tempted by opt-in non-probability web surveys. However, there's a lot of literature that suggests that non-probability web surveys may be less accurate than probability-based web surveys. So there are some trade-offs between probability-based web surveys and non-probability-based web surveys in terms of costs as well as accuracy. And what I want to show you now is one project that I've been working on to supplement probability sample surveys with non-probability sample information to reduce costs and increase estimation efficiency. So the context for this problem is, let's say a researcher is interested in making inferences from a probability sample survey, but they cannot afford a large sample size. So the alternatives are to reduce the sample size, so to field a small probability sample size survey, and tolerate the fact that there will be larger variances, but potentially unbiased estimates. So we reduce the sample size, which, because it's a probability-based survey, should still lead to unbiased estimates in theory, but the variance estimates will be larger compared to a large sample size survey. The other alternative is to opt for a non-probability sample survey, and try to and even though it may have more bias, try to reduce the bias by applying some weighting adjustments to that survey. The evidence suggests that even weighted non-probability sample surveys, even weighting these surveys doesn't eliminate the selection bias. Compared to a probability-based survey. So we may have to tolerate a larger bias, but a potentially lower variance from these non-probability opt-in surveys. So the proposal that my team has been working on is trying to integrate both of these types of surveys, non-probability survey with a probability survey, we assume that the probability survey is high quality, even if it has a smaller sample size compared to the non-probability survey. But that the probability survey will have larger variance because of that smaller sample size compared to the opt-in non-probability survey. So is there a way that we can combine these two surveys in a way that, uses each of their strengths to offset the limitations, including the limitations of probability sample surveys, which are higher costs and larger variance, versus the limitations of the non-probability survey, which has a higher selection bias and potentially lower quality. So the basic idea here is to field a small probability sample survey, a probability sample survey with small sample size, and a larger non-probability sample survey in parallel, collecting the same variables in both survey, and to integrate both survey data sets under a Bayesian framework to improve inference on regression coefficients and reduce survey costs. And so again, here inference is based on the small probability sample survey data. This is our likelihood, which we assume is unbiased and has high variance. And here we incorporate the potentially biased non-probability survey data source as a prior in the estimation process, which we assume here has low variance, but larger bias. And so the posterior estimates here are likely to have more bias than the probability sample estimates alone, but possibly less variance. So we might be able to produce posterior estimates that have a smaller MSE because of a smaller a reduction in the variance, but tolerate a potential increase in the amount of bias. So the aims here are to enhance inference compared to a standalone probability sample only, which is our gold standard. So can we reduce the mean squared error by incorporating this non-probability sample information into the estimation process? And by doing so, can we also reduce costs? Can we obtain at a lower cost the same MSE that we would obtain analyzing a much larger and costlier probability sample survey, probability only sample survey? And there's good reasons for applying a Bayesian approach to this problem. It's a natural choice to integrate data with varying levels of quality. And by treating the probability sample data as the likelihood, we can incentivize higher quality data. The more data points, the more probability sample data points that we include in our likelihood, the more influence that the probability data has on our posterior estimates. So we compared different priors. The first prior is just a baseline prior where we just use a weakly informative prior, just using only the probability sample data. And so this is our reference prior. And then we looked at some informative priors that incorporate information from the non-probability sample survey. And essentially, we looked at a series of distance priors where we compare. We compare the survey estimates from the non-probability survey with the same estimates computed from the. We compute the estimates, the same estimates computed from the probability survey with the non-probability survey. And if there's a large distance between those estimates, then we kind of assume that the non-probability sample survey is more biased, and so here we incorporate that information into the into the scale parameter and increase the variability in our prior distribution, so that so that the posterior estimates are less influenced by the non-probability survey data. However, if we do see good correspondence between the probability and the non-probability sample survey estimates, then the scale parameter becomes tighter. And then we borrow more information from the non-probability survey data in order to reduce the variance and increase the precision of our estimates. We also looked at some other priors, including a power prior. And so here, looking at some simulations, we can see that. So here are the results from the mean squared error for different scenarios, including high bias in the non-probability survey data and no bias. The solid black line denotes the mean squared error for the baseline, which doesn't incorporate any non-probability information, and the other lines denote the MSE for when we integrate the non-probability sample information. And we also looked at different sample sizes for the probability survey. So if you have a probability survey with just small sample size, 100, 200, 300 cases, the non-probability survey had sample sizes roughly around 1,000 to 5,000. So we can see here that there is a reduction in the mean squared error by using this data integration procedure, using priors that are derived from the non-probability surveys. Especially for the small sample sizes of the probability survey, we can achieve a significant reduction in mean squared error. Even in the worst case scenario where we have very large bias, a large selection bias in our non-probability survey, the informative priors perform just as well as the reference non-informative, the weakly informative prior. So in this case, we can't do any worse than the baseline prior, even in the case of large selection bias. I want to wrap up. I know I'm running out of time here, so I just want to just highlight a real data application of this applied to the American Trends panel. This is a probability online survey panel, and there was also 9 non-probability online surveys that were conducted, collecting many of the same variables. And so here we applied this method looking at a variety of different variables, including current smoking status, which I show you here. And here we can see that it might be hard to see. The font size is quite small here. But the informative priors do quite a good job of reducing the median mean squared error for most of the coefficients in the model compared to the weakly informative prior. And most of that reduction is driven by the reduction in variance, which we see in the middle plots. Where there is quite a significant reduction in the median variance, especially for the smaller sample sizes. And on the top here, we can see the bias. And so we definitely see a larger bias in the informative priors, which we would expect because the non-probability surveys are likely to have more bias than the probability sample surveys. At least that's our assumption. And so even though we do see an increase in the median bias, the reduction in variance offsets that increase in bias which leads to a reduction in the mean squared error. And so by looking at by carrying out a cost analysis, by comparing the mean squared error under different informative and weakly informative priors, we can achieve a cost savings for some of the priors. So if we attach a cost to each probability sampled unit and each non-probability sampled unit, and we created a Shiny app where you can actually use these results and enter different cost parameters for the per respondent probability and per respondent non-probability costs. And then it will calculate what is the expected cost savings for different priors and different probability sample sizes. And in the best case scenario, we see substantial cost savings up to 67%. But this also varies quite a lot between different priors and different probability sample sizes. So if that's something that you're interested in playing around with, I'm happy to share the link to the Shiny app where you can enter different cost parameters. So just to wrap up, from what I've seen, there's a growing interest in methods and applications of data integration, both for survey methodological and substantive research. And there's even more special issues forthcoming. You may have heard that the JOS, Journal of Official Statistics, recently closed a call for a special issue on data integration. The same for the Journal of the Royal Statistical Society. They will also have a special issue forthcoming. So this is clearly a hot topic, and I think interest in this area, in this field, will only continue to grow in the future. Pertaining to the topics that I focused on and in my own work, obtaining consent from respondents, I think this will only continue to grow in importance, both from a legal and ethical standpoint. We are in regular contact with our lawyers at my institute to see what the consent, how we need to acquire consent from respondents. We've already done a lot of work in the household survey context, but now we're starting to shift more to our establishment surveys. Previously, we never had to ask establishments for consent to link to their administrative data, but our lawyers and we're discussing this issue right now, and it's likely that we will start inserting more consent questions into our establishment surveys. In terms of non-response, harnessing the full potential of administrative covariate information may improve upon current non-response adjustments. And this is clearly what we saw in our IAB surveys. I'm also working with a postdoc right now in Iceland, where we're experimenting with different sets of administrative covariate information to include in their labor force survey, which they haven't previously used in their non-response adjustment. So we will see whether including additional administrative data leads to improvements in non-response adjustment methods. And lastly, combining probability and less expensive non-probability samples. Here, I think there is promise in which we can potentially improve estimation efficiency and reduce costs. There's also a couple of applications of this method that I've been involved with during the COVID pandemic, where there was a heavy reliance on non-probability web surveys and very small probability surveys, and combining these two different types of samples allowed us to increase the efficiency of the estimates. So I do think that there is potential here to improve estimation efficiency as well as reduce costs by leveraging or combining both of these sample types. So that's all from my side. I want to thank everyone for your attention, and happy to share the slides or references with anyone who would like them. So thank you for your time and your interest.
Thank you, Joe, for your very informative talk. Okay, now we open to the floor for questions. We'll take some questions for 5 minutes. Okay, you can either type your questions into the chat, or you can raise your hand, and then we will unmute you. Okay, Song Kyung Lee raised the hand. Okay, you can unmute yourself.
Looks like that person lowered their hand now.
Oh, okay. So, Joe, I have a quick question to you. You mentioned that the machine learning methods don't work as well as traditional methods in terms of reduced bias. Do you have any speculations on that?
Yeah, I mean, it looks like, at least in this case, I mean, I can only speak for this specific case study that we looked at. The response process, and this wasn't a business survey, this was an establishment survey. So the results might differ for household surveys where the response process may be more complicated. But it seems like that that explaining the response process for establishments is I mean it can basically be explained by just a couple of by administrative variables, and there doesn't seem to be any or it doesn't seem to be any substantial interactions between characteristics of establishments in their likelihood to participate. So that there doesn't seem to be any complex like subgroup response patterns that could be better explained by these machine learning methods. So just by using a standard logistic regression without any interaction terms, we do just as well as the sophisticated machine learning methods with interactions and higher order terms. So yeah, at least for this example, for this case study, it seems that the response process is fairly straightforward, and there doesn't seem to be a lot of differences between subgroups that would necessitate higher order terms and interactions. That's the best explanation I can provide.
Yeah, thanks. Dave Toto has a question. Dave, can you unmute yourself?
Thank you. Thanks for joining us, Joe. Very informative talk. I work more on the sort of behavioral side of response process and decisions about participation. And one thing I found really interesting in the first part of your talk was about the framing of different kinds of messages in terms of data linkage being a gain versus a loss. I wonder if you might share what you think or speculate about what different kinds of thought processes are going through respondents' minds as they respond to those kinds of different framing of messages.
Yeah, I mean, I think, I mean, the results made sense to us because, and the way we framed the question, I think, is important as well. So we essentially framed it. Maybe I can go back. So yeah, here's how we framed it. I mean, for the loss framing, we tell the respondents that the information that you've provided so far would be much less valuable to us if we can't link it to these administrative records. And this question was asked towards the end of the survey as well. So respondents had already answered the majority of the questions. So they've already put in a lot of effort in answering these questions, and so you can also think of, you could potentially think of this as like a sunk cost issue, where the respondents have already sunk so much of their efforts in answering these questions. And now we tell them that all of the work that they've done has been it could be much less valuable to us if we can't link it to alternative data sources. And so I think that's a pretty compelling argument to motivate respondents to consent to that linkage. Whereas whereas in the gain framing, yeah, I think this goes back to prospect theory, and people are more they're more sensitive to these to risks than they are to potential gains, and so even though you're telling them that the data they've provided to you will be more valuable to us, it's not as compelling or salient to them compared to arguing that the data would be much less valuable. So I'm not an expert on prospect theory, but I believe this is what Kahneman and Tversky found, is that people are more sensitive to risks than they are they're more sensitive to potential risks than they are to guaranteed rewards. That's the thought process behind it.
Okay, there is a question from Rebecca Morrison. I especially appreciate your comments on consent to link data. I'm wondering if you have any information, resources, or references related to gaining consent, assert to link data from minors, those in the US under age of 18.
Unfortunately, I don't. This is not a population I've spent much time studying, unfortunately. Yeah, but I can imagine that this brings up other issues as well in terms of acquiring consent. I'm sorry, I don't have any references on that issue.
Okay, thank you again, Joe, for your presentation and your time. I would ask everyone give Joe a big applause. And then the next session will start at 15 in 5 minutes, 10:15. Okay.
Thank you, everyone, and I hope you enjoy the rest of the conference.
Welcome and thanks for standing by. And welcome to session 1A, Advances in Online Surveys. Currently, we're only on a listen-only mode until the moderator announces a question and answer verbal part towards the end of the presentation in this session. Today's session is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn the session over to your moderator, Robin Kaplan. Robin, you may begin.
Hi, good morning, everyone. You are in session 1A, Advances in Online Surveys. We have 5 great presentations for you today. So each speaker will have about 15 minutes to present their talk, and then we'll do a final Q&A at the very end. If you have any questions throughout the sessions, feel free to use the chat to submit your question, or at the end, if you want to ask a verbal question, you can raise your hand and we will call on you then. So again, thank you all for being here today, and I'll go ahead and introduce our first speaker, who is Ting Yan from Westat, and their presentation is titled Revisiting Total Survey Error Framework in a Multi-Mode and Multi-Data Environment.
Can you unmute? We don't hear the speaker.
Okay, can you hear me now? you so much. Thank you, Robin. Again, I am Ting from WestEd. Before I start, I want to acknowledge my co-author, Wendy Hicks, also from WestEd, who is very instrumental to this work. Okay, so we all know the challenges we're facing now. Response rates are declining, cost of data collection is rising, and the plenary talk also speaks to this challenge we are having. So as a result of that, the single mode surveys are no longer fit for purpose in this environment. And we're turning to using multi-modes to contact people and to interview people. And following the survey literature, we make a distinction between contact mode, that is the modes we use to contact sample persons, and response mode, that is the modes we use to collect information from people. And there are 3 different kinds of multi-mode survey designs. As you can see, as I highlight the multi-mode designs in light blue boxes. Researchers have also now introduced other data sources with or without survey data collection directly from respondents to further address response rate declines, shrinking budgets, and shortened schedules. And again, in the plenary talk, Joe used the word data integration. There are all kinds of data out there that we know. There are administrative data, and there's data passively collected through sensors and wearables. And then we ask people for their biospecimen, and there's social media, out there. And these data are now used to contact people and to access people and to access their information, most importantly. So I'm showing you a fake example of how the different modes and the data sources can be combined in one data. It looks crazy, but it's not unfamiliar, right? A lot of studies are using, have part of the design features that I'm showing here. So for today, our talk is really motivated by this kind of environment when we're using multiple modes and we have data from multiple sources, and when we combine them, we need to think about the error components. And with this method, now we're really working with a total data error framework. And if you think back at the time when the TSE total survey error was first introduced, we're now at a similar juncture, facing gaps in our knowledge on the error components introduced by the incorporation of data from multiple modes and multiple sources. And the plenary talk is a great example of showing how we're trying to get there. But here in this talk, we're just gonna show that how we can expand this total survey error framework to systemize our research along this area. So just a very quick review of total survey error. I'm sure I don't have to spend a lot of time on that. The goal of total survey error framework is to reduce error given cost constraints, or alternatively to reduce cost for a given level of qualitative error. And a survey error is simply defined as a deviation of what is desired from what is attained. On the right side of the chart diagram, you see the different sources of error of non-observation. And on the left side is the errors of observation. Now we built on this TSE framework, but we expanded to a total data error framework to be fit for purposes for today's multi-mode and multi-data environment. And same as TSE, the goal is also to reduce error given cost constraints, or reduce cost given level of error. We believe that a multi-mode and multi-data designs, when designed and implemented correctly, have the potential to improve quality, to reduce error components at each stage of the survey process, and to reduce cost. So in the following slides, I'm just going to use this diagram as a basis and then to walk people through this different stages. And when research has demonstrated the benefits of using multi-mode and multi-data designs, I'll mention those. But you can actually see there are, for some of the error components, there's more questions than answers. And then I'll also call that out to our attention. So switching to coverage error, survey researchers have, routinely have used multiple frames or data sources to improve coverage or to improve efficiency. For instance, the buffers uses 2 frames, cell phone RDD and landline RDD, to improve the coverage of the buffers of the general population in the United States. And let's just assume that a non-probability web panel, of course, has a coverage issue. It excludes people without internet access. But combining it with an address-based sample would improve the coverage by including the non-digital population. And in my example study I showed on the earlier slides, the target population is WIC recipients, and the address-based frame has a good coverage of everyone, right? But then combining an address-based frame with a list of WIC participants from administrative data records improve the efficiency of guiding to WIC participants. And then here, whenever we have to be mindful of the additional cost and the increase in timeline of getting another data frame, another source, data from another source. For sampling error, the surveys designed to make a population inference are really founded on the mechanism of probability sampling. Every sampling unit has to have a known probability of being selected. The size of sampling error depends on other design features, such as whether you're having a stratification variable, whether there's clustering you need to take account into, and most importantly, sample size. And moving to the multi-data environment, sometimes it's not really clear whether probability sampling is still being used or even still feasible. For instance, studies using a non-probability web panel are not involving probability mechanism, right? Sampling mechanism. It might be okay if the studies are now to make inference. And an efficient way, as Joe has illustrated in his talk, is what we call blended sampling. That is, we combine a probability survey with a non-probability sample and to improve efficiency to reduce cost. And here there's also a misconception that if we have big data with millions of records, we don't need to worry about probability sampling. But that's actually not true. If the intent is to make inference, probability sampling is simply needed. For surveys, non-contact and refusals are 2 major sources of non-response error. And one motivation for using multimode surveys is actually to increase the likelihood that people will be contacted through multiple contact modes, and to increase their likelihood to participate in the study by offering them multiple response modes. When we combine the data from different sources, for instance, in my early example, I asked people to wear a device so that I can track their physical activity instead of asking them to self-report on their physical activity. This could reduce their reporting burden and increase their likelihood to participate in the study. But then people have to give me consent so that I can passively collect their physical activity. So nowadays, non-consent becomes a new form of non-response error for studies combining multiple data sources. And then again, Joe talks about the non-consent for establishment surveys. But same thing for household surveys, non-consent is a big issue. It's ethical and we need to do it. Surveys traditionally use weights to increase coverage to account for differential sampling probabilities and to account differential non-response. The typical approach, assuming that all respondents should be treated the same regardless of mode, is going to be problematic for a multi-mode environment, because it is well known that response patterns vary by mode. And then I'm going to talk about that a little bit more in a couple of slides. So an adapted mode adjustment process that takes into consideration of this mode differences is found to reduce bias without increasing variance of the estimates. Now, adjustments sometimes becomes more challenging when multiple sources of data are combined. The auxiliary information required for adjustments needs to be available and mean the same thing across all data sources that we have. Joe demonstrated a great example where they have a rich administrative data that have a lot more information they need. But sometimes, we have to consider like the common variables we use for adjustments, like race and education. And are they, present everywhere in all the administrative data that you want to use? That's a question mark, actually. And the second question is, how do we make adjustment? Joe showed that machine learning may not be adding a lot of value there. So again, in this area, I think this is open area where more research is needed to answer questions. Now moving to the left side that deals with measurement. The first thing we are really, the first important thing is validity. For multimode surveys, it's really critical to ensure that the same construct is measured on all modes involved. And there are two approaches to design a questionnaire for multimode study. The unimode approach attempts to maximize equivalence across modes by minimizing differences in, for instance, question wordings, response options, instructions, examples, etc. By contrast, the best practices approach aims to take the full advantage of each response mode. And the attempt there is to actually minimize response error within each mode. Regardless of which approach you are taking, the critical thing is you just have to make sure the same construct is measured across all modes. And when we pull information from different data sources, again, we have to ask ourselves how confident we are about each data source having data elements measuring the same construct that we want to measure. So just giving you an example, the electronic health records data may contain information, for instance, of whether or not people get the COVID vaccine. Let's just assume that's the construct you want to measure. And then you want to combine the claims data. The claims data have formal diagnosis, but is that diagnosis measuring what we want to measure, given which is when people get COVID vaccine? So again, here we believe that a unified data element approach across data is a desired approach. Now, back to measurement error. For surveys using multimodes, survey methodology, survey methods literature have demonstrated that the differential mode measurement effects occurs. People tend to be more honest on the self-administered modes than on interviewer modes. As a matter of fact, a great example of using a multimode design to improve measurement is actually using self-administration to ask sensitive questions and using interviewer administration for other type of questions. For multi-data environment, we have to be worried about differential level of qualities. We know that data from some sources have more information than other data sources. Some data sources have more entry error than other data sources, and some are outdated, a little bit more outdated than others. So this is where we just have to make sure that how do we account for differential levels of quality in the multi-data environment. Post-survey processing is typically done after survey is completed. We have to code open-ended questions. We have to, edit out of range values, and imputation is typically done as well. For multi-mode environment, again, unified decisions and rules are desired, but we have to be aware that when we use multiple modes, we may run into differential amount of processing and differential processing error. And harmonization across different modes to take care of mode-specific instances take time and increase cost. And in multi-data environment is also a lot more trickier because some data are half structured, some are fully structured, some are unstructured. Then using a unified decisions and rules are desired, but very tricky. And sometimes we just have to adopt different rules leading to differential processing error. So when we introduce one mode and one more data source into the design to reduce one type of error, we have to be aware of, the possibility that you could increase another error in an unintended way. And we have to be aware that any data sources you introduce includes any mode you introduce into the design leads to additional cost, additional time. I want to end my talk by making a call for more research and to echo what Joe has talked about in his plenary talk. There's so many things that needs to be done. There's a lot of things that open areas that we actually don't know. I think it's a good idea that we start to use this paradigm to guide our thinking and to guide our research so that collectively we will understand each component error and the trade-offs between error and cost together to make informed decisions. Thank you so much.
Thank you so much, Ting. I'm going to introduce our second speaker, Anwar Mohammed from RTI International, who will be presenting on battling survey bots, experiences and strategies to mitigate fraudulent responses in online surveys.
Everyone, can you hear me? All right.
Yes.
Okay, thank you. So in this presentation, Battling Survey Bots, I'll be talking about some of our experiences and strategies to mitigate fraudulent responses in online surveys. I wanted to thank my co-authors, Matt Benson, Bob Henney, and David Schultz, who helped me with this presentation. Okay, so what is a bot? Bots are simple computer programs that impersonate people. Survey bots are created to imitate human responses in online surveys. Fraudsters and bot programmers can either make or they can even buy a bot program and set it up to automatically take a survey. And they can complete a large number of surveys in real quick time. They're also constantly finding new ways to make such bot responses appear as real as possible. So they're enabling them to give smart and logical responses, so which makes it believable that these are real responses. So how are these survey bots used or rather misused? Here are a few ways. Some government agencies or nonprofits offer incentives for giving out either gift cards or cash for completing the survey. Now the scammers can use these bots to fill out the surveys multiple times using email addresses that they own, which allows them to claim the bonus multiple times. Some surveys may offer a prize to random survey takers. Now, to maximize their chances of winning the prize, they may use the survey bots to repeatedly take the survey. Some agencies pay third-party organizations to deliver surveys to consumers on their behalf. The fraudsters may try to use bots to get multiple survey completes to earn that commission. Some companies may use bots to corrupt their competitors' survey results, giving them faulty data that doesn't reflect real consumer preferences. And some may use survey bots as a way to just conduct pranks or simply to harass, just because they can. Political activists with some hacking skills may use survey bots to cue political polls or marketing surveys to make certain political views, appear less or more popular than they actually are. Now, this can alter the public's perception of the political climate or about a certain party. So how can survey bots affect a business? There are many ways. The biggest one is wasted budget. Invalid online survey results represent a direct waste of any money that was spent on either creating, advertising, and distributing the survey, especially for a small to mid-sized business. Product surveys used to gauge public interest in a new product can help a company determine if it's worth their time and effort to spend money on R&D and manufacturing. But if that assessment is based on bad survey data, they could end up wasting a lot of money on a product that may not really succeed. Survey bots could indirectly harm a company's reputation with the public. They could twist polls about the company to make them look bad. And when a survey falls victim to a bot attack, the organization may become hyper vigilant, as does the client. Now, what this may result in is analyzing every data point that is either odd or looks suspicious, even though it's not really suspicious. So you end up wasting a lot of time and budget trying to evaluate data points just because you are worried that it is suspicious. On one of the recent projects that I had led, we had launched a survey that was intended to gather sensitive data from a hard-to-read sample. We had a $20 gift incentive to eligible respondents who completed the survey. This survey was developed using Voxco software, and we were hoping to receive about 1,500 responses in the 6-month data collection period. So we launched the survey successfully, and the responses were trickling in at the expected rate. It started off slow, but as expected, slowly it started increasing to about 10, 15, 20 per day, which was our expected rate. So we had less than 100 responses in about 3 weeks. So that was our target of achieving this. And then we hit lottery. We had 7,000 plus completes in less than a week. Now, it does not take a genius to realize something was drastically wrong here. So how do we identify which responses could have been from bots? Start with the timestamps, the time that the survey was taken or initiated. Bots frequently respond in clusters, attempting to get the incentives for completing the survey multiple times. Here we see multiple responses for the survey, which started exactly at the same time, even to the second. So this could strongly indicate bot activity. So if you notice here, there was a surge in responses, all bearing strikingly similar start time, even to the second, and also had identical duration for completion. Now, this is very uncommon, and this could also indicate bot activity. Also consider inspecting the actual timestamps, since it would be unusual to encounter groups of respondents finishing a survey at very odd hours. Say, for example, we see here a lot of completes at 4 a.m., which is very suspicious. The next is open-ended responses. It's critical to double-check these responses too. Human respondents will often input some text to quickly bypass any mandatory open-ended questions. However, bots tend to generate feasible words, but creating random or sometimes nonsensical phrases. Or bots may repeatedly provide the identical response each time they take the survey, as you can see in the example here. Review the metadata of all respondents. This includes all the IP addresses, the operating systems, did they use a Mac or a PC, the platform being used, was it on a desktop or a mobile device, and if it was a device, what was the device? Was it an iPhone and an Android, and additional details of the version, the browser version, the software version. So finding multiple responses with identical metadata can also serve as a warning sign. Speed. Bots can often complete survey at a very fast pace because unlike humans, they don't really require time to consider opinion-based questions. In our example here, for a 20-minute survey, the respondents completed the survey in less than 1/3 of the median survey length. Now, these responses should be scrutinized to check for the authenticity of these results. Straight lining. If your survey includes a grid type survey question like the Likert table here, if the respondents have to select rating for multiple statements, it isn't unusual for a few participants to choose the same response for all the statements. Now, this can happen with bots as well as humans who are not really engaged too much in taking the survey. They just want to fill up the survey. You can manually identify these or utilize straight line flags through programming to disregard any respondents that straight line answers to one or more questions, depending on the threshold that you set. In this example here, answering all the options for extremely likely did not make logical sense because we were asking them for what was the best option. So this is definitely a red flag and has to be investigated. So as I mentioned earlier, bots often answer in groups and submit noticeably abnormal results that should be examined based on the frequencies. So look for unusual frequencies within various demographic factors such as age, location, gender, education, or a combination of all these, because these can highlight discrepancies between the actual findings and your expected results. For example, an 18-year-old with a PhD degree, the chances are very unlikely. Look at some of these emails that we received. Now, what are the chances that someone would use an actual email for a daily use? These are all random combination of alphanumeric characters, and they all have the same Outlook.com extension. So how can we stop these survey bots? Here are a few methods. For years, CAPTCHA has been the go-to tool to weed out bot traffic. You must have used the classic I'm not a robot checkbox, or the jumbled string of letters and numbers, or the fuzzy pictures where you have to click where do you see the traffic light or a bicycle. It works as a basic form of stopping bots, but not advanced ones, as fraudsters have had years to learn how it works and how to bypass it. Using honeypot form fields. Unlike humans, bots directly read the code on the web page. So if you see in this example here, the respondent is going to see question 5 and question 6. But if we are inserting a form field which is not visible to the human respondent, the bots will still see that. And if you're getting responses from a question which was hidden from humans, that's a clear indication that the bot has responded to this question. So if there was a response to which ice cream flavor is the best, that is coming from a bot, because a human respondent is not able to see that question or answer it. Using email verification is one more way to thwart bot traffic. So instead of taking people directly to a survey, ask for their email and email them the link. But this extra step could discourage survey takers, and they may opt out of the survey, potentially leading to survey bias. And scammers also have control of dummy email accounts that they can use for email verification purposes. Check the consistency of the survey results and see if they are abnormally consistent. So if they are 95, 99% identical to one another, then it is suspicious. As we saw for the open-ended questions, how many respondents would have a word-for-word identical answer for an open-ended question? Using software that detects bots. Now, the software could calculate a fraud probability score, identify duplicates, evaluate IP addresses, and do a lot more. This helps you get rid of the fraudulent traffic without risking genuine survey responses. Review the survey taker metadata. If a bunch of survey responses are all coming from the same IP address or device type with the same operating system and specs, that could be a sign that someone is using a bot to fill out your survey repeatedly from the same device. And lastly, do not provide incentives. Confirm it either via SMS or email or some other method before you send out the incentive. For our CDC project, we considered multiple options to check, are you a human? Some questions were simple addition, subtraction, or some needing more logic, like a number greater than 7 but less than 10, which is basically the answer 8 or 9. Finally, we decided to add a question where the respondents had to enter the numerical numbers that was spelled out in words. So they had to come in and enter the numbers exactly as we had listed in the question there, 71935. They could proceed only if they answered it accurately. This worked because we saw great results. More than 67% dropouts were for the number entry question that was added, where they had to enter that numeric number manually. And to be extra safe, what we did was we changed this number, 5-digit number, at least once in a week, sometimes even twice, because we didn't want the number to be consistent or the same over the data collection period. So this way, the bots had to keep, if they had written this program, they have to keep updating it in order to fill out the same survey. At RTI, we have developed a platform, the survey landing page and information page system, or SLIPS as we call it, that allows for the rapid creation of websites to provide a layer of protection outside the survey engine. Each project starts with a base template with built-in security features such as collecting metadata information, the PIN and password validation, which is done via SLIPS, not inside the survey engine. So this is to prevent DNS attacks. SLIPS gathers session data for each arrival at the landing page. It also obfuscates the password length or pattern used by the respondents. We can also connect third-party fraud prevention software if it is needed. A lot of the surveys at RTI now use SLIPS. On an HIV study that had incentives, we captured the metadata and a fraud probability score. A session log was created for each arrival at the landing page. Now, we had a multiple choice question in the survey where we told the respondent what to answer as a pay attention question. We also had 2 open-ended questions. It was not really important for data collection that a person not in the sample might not be able to answer very easily. We did not pay incentives immediately. We compared and checked email addresses for exact matches and also for similarity. We reached out to a sample list of email addresses, and we also invited people to text in their phone number. A unique survey link was then sent to these phone numbers. Now, all these precautions really helped, as the data quality was very good with no red flags detected. So to conclude, bot prevention is an important aspect of online surveys, as it helps to ensure that responses are coming from real human respondents and not bots or other automated programs. Pay attention, as data security is the utmost importance, not just for our clients, but it's also a great way to protect our data. Have prevention methods in place during development, not after the fact. And use software. It could be commercial, there are a lot of commercial software available there, or it could be homegrown, as you saw with RTI's SLIPS software. Monitor the metadata on a regular basis and keep looking for any unusual activity or red flags so that you know there are no suspicious responses coming in. That concludes my presentation. Thank you.
Thank you so much, Anwar. We'll go on to our third presentation, who will be Alda Rivas from the U.S. Census Bureau, whose talk is entitled QR Codes as a Method to Access a Mobile Survey.
Robin, thank you very much for the introduction. Yes, start sharing my screen. Okay, can you see my screen? Can you see the presentation?
Yes.
Okay, perfect. Thank you very much. Again, thank you for the introduction, and I'm going to present to you the research that my team and I conducted, which explored the usability of QR codes as a method to access a survey through a mobile device. Okay, so a little bit of background about the current use of internet and smartphone in the United States is that, at least in the United States, about 93% of adults conduct activities online. 85% of adults have a smartphone that connects to the internet. And for about 15% of adults, a smartphone is actually the only device to connect to the internet. These rates are a little bit lower, but still follow the same trend for older adults in the United States, where about 75% of older adults conduct activities online, 61% have a smartphone that connects to the internet, and for about 12% of older adults, a smartphone is the only device that they have in the household to connect to the internet. And so given the high percentage of people that conduct activities online, it's not surprising that a wide range of activities have switched from being conducted in person or in paper to being online. So, for example, there's more and more people that are completed surveys online. And the best example is the 2020 census, in which about 80% of self-respondents actually completed this form online. The problem is that entering a web address in a smartphone can be very cumbersome, particularly when the address for this survey is for any web page is long, or it may require an alphanumeric string, which is the case for censuses. This is a particular challenge for older adults because of the decline in fine motor movements that is associated with healthy aging. So a potential solution to this issue is to provide potential respondents with a QR code on the paper invite, or a quick response code. A QR code is a matrix code that consists of black and white squares and is used for storing information, mainly URLs. The QR codes are read through different types of scanning device, but something like an example is the camera on your smartphone. And actually, QR codes is a technology that has existed for about 30 years, but they became more popular, more mainstream after the pandemic. Some of the potential benefits to including QR codes on paper invites is that it could help census leverage technology to encourage survey respondents, improve the user experience of respondents, reduce their burden, and potentially even reduce costs associated with post-processing, like non-ID linking, like no response follow-up or phone support, etc. There has been some research exploring response rates through QR codes. In Marlar 2018, Marlar conducted a study in which they have three different experimental conditions. The first condition is that they made paper invites and they provided a URL in the paper invite to complete a survey. The second condition included a QR code to access the survey instead of the URL. And then a third condition had the two options, a URL and a QR code to access the survey. And the three different conditions, they all also included the option to just mail back a paper survey. Marlar found no difference in response rates across the three conditions, but they did find that only 4% of respondents chose to access the survey through a QR code. And actually, the condition with the QR code only had a higher response rate through paper compared to the other conditions. So they concluded that it was really not that much improvement in including a QR code in a paper invite. A couple of the limitations of this study is that, one, the study was conducted in 2017, before the pandemic, before QR codes was such part of the mainstream like they are today. And the instructions only included the wording, scan the QR code to access the website and complete the survey online, which for a technology that is not that spread out, that well known, it may not be sufficient detail in the instruction for someone without experience to be motivated to use this process to access the survey. And so there is need for new research. The current prevalence of QR codes in the mainstream, combined with maybe more detailed instructions, this may be possible to make QR codes a viable option to complete a survey on a smartphone. So we developed a couple of research questions. The first one is, what is the usability of QR codes as a method to access a mobile survey? And what is the optimal wording of instructions to allow people without a previous experience on QR code to be able to access a survey through this technology? In order to answer these questions, we conducted a couple of studies, a couple of usability evaluations. The first one was with the general population, just a general invite online, was conducted in the summer of 2022, and it was conducted remotely. The second one was a second usability evaluation, specifically with a sample consistent of adults who were at least 55 years old. These sessions were conducted in person, and it was conducted in the fall of 2022. And the findings from this second usability evaluation, we published them last year in lecture notes in computer science. So the first, I'm going to talk first about the first round, the usability evaluation with the general population. For the sample, we had 20 iPhone users with an average age of 29.9 years, so relatively a young sample that responded to our invitation to participate. They completed a usability task where they started completing a survey on the desktop or laptop, and then at some point in the survey, they were presented with these instructions on the right to continue the survey in their smartphone, and it included instruction on how to scan the QR code. What we found is that the whole sample was able to access the survey through their smartphone using the QR code, and they did so in an average of 12.4 seconds. The whole sample rated the process as extremely easy, and 90% of the sample said that they were likely to access the survey using a QR code. There were absolutely no usability issues. No one encountered anything in the process that prevent them or delay them from accessing the survey through the QR code. So we asked this sample for feedback about the instructions that we developed to allow people without experience using QR codes to be able to use this technology. So this is the instructions where we got feedback. 1, open your camera app. 2, hover over the code. And 3, follow the link. What the users express as a potential way to, as a possibility that either older adults or non-tech savvy people would prevent them from using the QR code is that maybe they don't know that they're supposed to use the app, the camera app on their phone. Maybe they don't know what hover means. They don't know what the code is, and they don't know how to follow a link. They may not know what this means to follow a link. So we went ahead and took this feedback and modified the instructions, and then conducted a second round of usability evaluation with older adults. We were hoping with this with these characteristics of this sample, we were hoping to get more participants who didn't have previous experience with QR code. So for this second round, we had 19 users with an average age of 63.68 years. And we recruited and collected the data in community centers in a metropolitan area in Texas. The usability task is that we gave participants a paper invite and we gave them these instructions. Imagine that you are at home and receive this invitation in your mailbox. If you wanted to complete the census following the instructions in the invite, what would you do? This is the invite that they saw with the modified instructions. And what we found is, first of all, for the sample, we had 10 users who already had previous experience with QR codes, and 9 users had no experience, but they were familiar with QR codes. They had all seen them before. They had a good understanding of what they were used for, or had seen someone using them. For the users who were able to access the survey, they did so, which was 74% of the sample. They did so in about 31.21 seconds. And for satisfaction, we measured it as difficulty and preference. For difficulty, there was a median of 2.10, on where 1 is extremely easy and 7 is extremely difficult. And for preference, 16 out of the 19 participants stated that they would prefer to scan a QR code. 2 participants said that they would prefer to type, and 1 expressed no preference between the 2 options. So, we did find some usability issues in this second round that either prevented or delayed users from accessing the survey using the QR code. The main issue that we observed is that the presentation of the notification, when you scan a QR code, you get a notification on your screen, and then you're supposed to tap or follow that link. The problem here was that this notification is not really standardized across different operating systems. There are different operating systems presented in different way. And users were not able to recognize that this notification was actually the link that they needed to tap to open the survey. We had 2 users who were unable to complete the task, and 8 users that were delayed on the task due to this specific issue. And this is what I mean. Different operating, have here screenshots from different operating systems. All of this is after scanning the QR code, the one on the left, the notifications appears in the top, and actually some participants of these sessions thought that someone was trying to text them and that there was a notification, so they would just swipe it away. Another operating system shows the notification at the bottom, and another notification system, another operating system shows the notification as a small yellow bubble close to where the QR code is. So like I said, like there's different ways, it's not really standardized. And so it's really hard to make instructions to be able to address this issue, since there's so many possible ways in which this notification can be presented. So this was the main usability issue. I'll go through another usability issue and then move on for the sake of time. The second usability issue is that a couple participants were not clear about how to focus the QR code on the camera. One user opened the camera and focused the whole invite instead of just the QR code, and another user focused the stamp in the postage stamp in the invite instead of the QR code. I'm gonna move on for the sake of time, but we had another couple of usability issues that we observed, like not knowing that they have to maybe select the browser first with which they want to open the survey, or that they don't have to take a picture. So those are the main issues that we observed with this sample. So based on this, we had some recommended changes to the instructions. Specifically, we want to specify do not take a picture. We labeled the QR code more clearly as such and provided a graphic, hoping to get to portray a little better idea of how the QR code is supposed to look on the screen when you're trying to focus it. Some of the limitations of this study is that most of the usability issues, the main usability issues, are outside of our control. For, like I mentioned before, the presentation of notification across different operating systems. There's different steps to complete across different operating systems. So this is really up to the technology owners to be able to standardize this or make it more usable. We could try to modify the instructions in the paper invites to address these issues, but the truth is that there's so many ways in which, for example, the notifications are presented that is really not realistic to be able to include this instruction in the limited space of a paper invite. The good news is that this process showed to have high usability. There was a high effectiveness. 14 out of 19 users completed the task. There was a high satisfaction with 16 out of 19 users stating that they would prefer to scan a QR code than to type a website on the smartphone. Mind you, some of these users did not have previous experience using QR codes. And even though some of them have experience, not all of them did, but even the people who did not have previous experience using a QR code, they were all familiar with it. They all knew what it was, had a good understanding of what it used for. They have seen someone using it, etc. It's not something that no one expressed this being something that they have never seen before. More good news is that it's a process that seems to be easy to learn and that prevents mistakes. Some users spontaneously express being happy about the current prevalence of QR codes because it helps them prevent mistakes and motivates them to visit a site. Someone stated that they would think twice before opening a web page if they had to type. They also stated that this process is easy to learn. One user spontaneously stated, once you've done it a couple of times, you won't have any problems. So in conclusion, given the widespread presence of QR codes in daily life activities and their high usability, and the fact that it was described as an easy to learn process, then we conclude that including a QR code in a paper invite is a viable way for respondents to access surveys through a smartphone. As for future directions, we would like to conduct new rounds of usability evaluation, potentially with Spanish speakers, to see if there are any differences in how familiar different samples are with this technology for different languages. And that is it. Thank you very much for your attention and for your time.
Thank you so much, Alda. I will go ahead and introduce our next speaker, who is Matthew Benson from RTI International, who will be presenting on transitioning in-school paper survey to online administration.
Thank you. I trust you can see my screen.
Yes.
Okay, so my co-authors are all of us from RTI: Brian Rhodes, Gene Robinson, Sarah Carter, Elizabeth Parrish, and Scarlett Pushy. So Project Basics, our client is the South Carolina Department of Health and Environmental Control. The survey is the South Carolina Youth Tobacco Survey, and the goal is to collect data toward preventing and reducing youth tobacco use. So today I'll talk about reasons why to switch this paper-based survey to a web-based process, what additional elements became programmatic or more programmatic, some of the challenges we encountered, information about the 3 main surveys we employed, how we connected these 3 surveys to each other, and a bit about our dashboard. So the surveys, there was the listing of classes survey in a particular period, the student survey, and a teacher administrative data survey. So the protocol this time around with a web-based approach is pretty much has a lot of similar components to when it was paper-based. And that is, we recruit school representatives, a school rep in each school, and each participating school rep lists classes that take place in a particular class period, so say second period, so all students are accounted for. The school rep provides us their listing, and we use a statistically based method to select the classes. The school rep is informed of which classes were selected. The school rep disseminates the information or materials to teachers, and the students take the survey. So some elements became more automated, so the collecting of the class list data became more automated. We'll see that. The selecting of the classes was done programmatically, and the taking of the student survey was done electronically. So why switch to electronic data collection? Well, you don't have to deal with all that paper. Imagine the job of first getting the right quantity of paper that you'll need for the amount of schools that will participate, sending it in the right quantities to each particular school. Then at the school level, the school representative gets it and has to get the right quantities and get it to the right teachers, has to keep track of when the survey is going to be implemented, has to collect it, package it up in a good way, send it back, then it has to be scanned, and then after the scanning's done, it has to be held in a particular place, stored, etc. So easier to do it electronically. Also, we feel it could lead to improved data quality. So here you see a picture of a bubble sheet, and this is akin to how South Carolina students took the youth tobacco survey. In the past, they had a booklet with the question text on it and answer options, and their job was to map their answer options to the bubble sheet. So you can imagine some students may get sick of it, maybe not try, and others just may make an honest error of mismapping, which is bad for data quality. Of course, what you see below is an example from the electronic survey, just everything is right in front of the students, so that should help. Also speed. When we collect data electronically, we get the data as soon as students start answering. Not all schools take it at the same time, so we're prepared to immediately look at the data as they come in and check it for completeness, get patterns, etc. So a bit about obtaining the lists of classes, comparing the past and what we did this time around. So in the past, this is a portion of a message that a school rep would receive. And here they're thanked for their participation, and they're asked to submit, in this case for a second period, the class schedule. They said by PDF or Excel is good, and they send it via email. So you can imagine the recipient of this information, if it's an Excel file, they've got another document open, which tells them which classes should be selected, and perhaps they're highlighting in the Excel file the classes. If it's a PDF file, they need to translate that into perhaps an Excel file and then do the same highlighting of classes. And then in the end, creating tables with just the selected classes, inserting them into an email. So it's a decent amount of manual work. So we sought to minimize that. And so one thing we did is we created a survey, a data collection instrument where each school rep had a unique link to get in. And in that data collection instrument, a school rep could upload their class listing. We specifically asked for that uploading to happen in Excel. A school rep, if they didn't have a template, could also download an Excel template through the data collection instrument and then upload it when it was completed. Also, we offered the school reps to provide their class listing within the instrument itself, and you can see an example of that in the screenshot. We collected the school rep email address through the instrument, and so the notion here was to be able to have all our information and be able to use our programs to generate a table that has all the information needed and to just programmatically send the email as well. But we did run into some difficulty, and that was our SAS programs depended on getting the class listings in a format that we could work with. And in some situations, we got more columns than expected. We got columns in the wrong order. We had special characters, some other formatting issues. So that presented some challenges. Having said that, we don't think it cost any more time than the old way, and hopefully we can make this better as we move forward. So here is a table that was produced by our programming that would go to a school rep, and then the school rep would pass this along to the teachers. And here you can see it's all the classes that were selected for a particular school. And there's a unique student link unique to the class at the class level. And then there's a link for the teacher to do their teacher administrative survey, and that's unique specifically to that teacher. There's a code word there that I've got blocked out. I'll talk about that in a little bit. So the connections among the surveys. So we started out just as soon as we got the sample that we assigned case IDs to each school and created a unique PIN for each school that the rep would use to access their survey. Then once we got the class listing survey in from a school, our programs would run and class case IDs would be created. And you could see, look at the bottom, please. And in this hypothetical example, after we did the necessary sorting of the listing of classes by grade, which of course we did automatically, programmatically. In this particular example, it's that the third class in the list is selected and the fourth class is selected, and that corresponds to the class case IDs that we created for tracking purposes. And also at the time that we created the classes, we assigned a code word for that particular class and also the teacher specific PIN. So getting into the survey. So in that table I showed a moment ago, there was a complete URL. So if the teacher was able to distribute the URL in its entirety, the student could just click on the link and they would be taken directly into the survey. But if the teacher, for example, just put the base URL, for example, on the whiteboard, then they'd be taken to this landing page where they would enter their code word, in this case, pony, and then be brought into the survey. The idea here for the code word is, we needed to know to what class each student survey belonged to. So in the paper-based world, it's pretty easy where you've got the bubble sheet, one bubble sheet in front of each student, but it's different in this world. And we wanted to account for the possibility of a student potentially getting disconnected. Perhaps there's a fire drill or loss of power or other reasons. So we wanted them to be able to reconnect to a survey that they already started. So toward the beginning of the survey, we had, if you previously started the survey and would like to pick up where you left off, click here. Otherwise, click Start Survey. So in almost every instance, Start Survey was selected, and then they're brought into the beginning of the substantive portion of the survey. And then in the footer, this Your PIN is started to appear, and it was an alphanumeric, and it was unique to the survey entrance, and the instructions to the teacher prior to the students taking the survey was to ask the students to take a picture of this with their phone or maybe write it down in case they got disconnected. And if they did, and then they re-entered, then if you previously started the survey and would like to pick up where you left off, click here, they would go here, they'd enter their PIN. If their PIN was a true match for a PIN that existed, they'd be brought back into the already started survey at the place where they left off. If the PIN didn't match, or if they chose I don't have it, they would just continue on in that survey instance. So here's just a bit about the teacher survey. It basically asks for what was going on that particular day that it was implemented, the student survey was implemented, provides us context. A bit about data visualization. So we were able, through a dashboard of sorts, to track how our recruitment of schools was going across time, how the teacher completes are going across time. And then at the school level, we had data such as where we combined data from different survey sources. We had the enrollment number, how many completes we had, how many absences there were on a particular day, how many opt-outs there were. This isn't active here, but we could hover over a bar and that would provide us that same information, or we could drill down to the class. So considering for the next time, one thing we might do is we might ask for the class listing files to be CSV files or plain text files. We're thinking that might help deal with some of the formatting issues that made us have some human intervention before we ran our programs. One challenge here is we're in the, we're trying to recruit these schools to participate, and it's not easy to do that. So we don't want to be too heavy-handed because we really value participation, but that's one idea. Also, where we asked students who got disconnected to enter the PIN we provided, first, and thankfully, there were a very small number of students who said they were disconnected, but a very small percentage of those actually provided a correct PIN. So we want to try to figure out what happened there and what we could do better in the future on that. Also, there was one example where we got a report that the students couldn't enter the survey, and it was because of the security setup that the IT staff at a particular school had. So just providing perhaps some directions to make sure to the school rep that everything is all set for that. But in summary, it worked. We're still in data collection, but we've had about 18 schools participate so far, and the survey data is coming in, and we're not hearing any complaints or difficulties. We have a separate survey where we're asking school reps about the experience and the responses we've gotten so far. No one has complained about the doing electronically or the process of the class listing. No one has even suggested something we do differently. So that's all going well, and we were able to check out the data as soon as it started coming in, which is great. And we haven't assessed the data yet, and our client hasn't, but we're hoping we'll be able to show improved data quality. So, thank you.
Thank you so much, Matthew. I'll go ahead and introduce our final speaker. We'll be hearing again from Ting Yan from Westat, who will be presenting on using machine learning to identify careless web respondents.
Hey, thank you, Rob. This time I have more Westat co-authors to support me, so I want to acknowledge their contribution to this work. Just an acknowledgement, this work was supported by a grant from the National Science Foundation. We acknowledge their contribution. I don't think I need to convince the audience attending this session the importance and popularity of web surveys. And then I probably don't need to talk a lot about the known data issues faced by the web surveys, as the previous speakers have already talked about some of the issues and then the both the pros and the cons. And I just want to say for this talk, I'm focusing on the measurement error property of web surveys. And specifically, I'm talking about two types of web respondents of concerns. And the first one, again, our previous presenters have touched upon that. I'm making a distinction between two types of web respondents who may provide us data with questionable quality. The first type is what I call fraudulent respondents. It includes bots, as the previous speaker has talked about. It also includes what I call fake respondents. So these are the people, they actually live outside the targeted area. For people who work with web surveys, especially using non-probability web panels, we are aware of this type of people. You want people living in the United States to answer the questions, but you see a lot of people from Venezuela, for instance. And the third kind of fraudulent respondents are, multi-completers. They come in the surveys and try to answer it multiple times on multiple devices. And this could be individual or it could be a more organized process like the click farms. And lastly, there's the ghost respondents. Basically, they are hackers who somehow, who can override the transfer process, and then they just ended up, as a complete without actually completing the survey interview. And the second type of web respondents are what we call careless respondents. It has, again, different names in the survey literature. They're called inattentive respondents, insincere respondents, bogus respondents, satisfying respondents. They're different from the first one in that they are really, they're real human beings who are not who are not bots, who are not from the click farms, and they're not ghost respondents. They're trying to complete their web survey. But the problem with this type of respondent is that they are not really exerting the kind of effort we want them or required of the survey response process framework. So, we see them, participate in the survey, but they don't read the questions carefully. They don't follow the instructions. They don't spend time to recall, the information needed to answer the question. And then they don't bother to, put all the recall information together into an estimate or judgment. And they claim, they multitask while doing the surveys, and they're distracted. In a way, they're just not motivated. They're unmotivated. So because of this unmotivation, distraction, multitasking, satisfying, we really worry about the kind of data that they provide to the web surveys. And this type of people is the focus of this talk. I want to find out how we can catch them, identify them. So the question is, why do we care, right? I created this table based on a work by Kennedy and colleagues. They showed that the careless respondents do provide very different opinions and different behaviors than the rest of the participants. So the blue bars in this chart are careless respondents, and the red bars are everyone else. And you can see the differences between careless respondents and their other counterparts sometimes are quite substantial. So that's why we care about this group of respondents. Survey researchers are actually aware of this type of respondents all along, and they have used many methods to identify them both during data collection and after data collection. Again, the previous presenter has a nice list of all the things you can see. They try to catch a bot, but the same methods can be used to identify careless respondents. So the survey researchers have routinely used attention checks or trap questions to catch respondents who are not paying attention. And Conrad and colleagues showed an example, a great example of catching people who were trying to speed through the questionnaire and provide an intervention to improve their behavior. And there's also research where people use the low incidence question. That is, no one is supposed to say yes, but you see people who answer yes nonetheless. And then also the inconsistent answers, like the 18-year-old getting a PhD, as mentioned in the previous talk. And also there's proxy indicators of data quality are examined either alone or together for careless behaviors. And these are mostly driven by the satisfying response framework. So we look at their straight lining as demonstrated in the previous talk. We also look at extreme responses, midpoint responses, acquiescence, and missing data rates. And Kennedy and colleagues also talk about a innovative use of open-ended questions to detect careless response behaviors. And response entropy is a little bit different from the previous methods. It is a data-driven approach that looks at the degree of disorder in a person's response choices on a set of survey questions. So a higher entropy score suggests that the response are two-ordered. And an example of what I mean by two-ordered is that respondents always select the first response or always straight line, then their response set is two-ordered. And that's a bad behavior. I mean, that's an indicative of careless responding. By contrast, a score that is too low would indicate that responses are too disordered, too random, too scattered. So which could happen when respondents, basically answer questions without any consistency. They just, randomly pick whatever answer. So as you can see, both too high and too low of entropy scores are indicative of careless responding. So in this talk, we explore the use of machine learning to identify careless responders. Specifically, we used 4 unsupervised clustering methods. The advantage of using a unsupervised algorithm is that the algorithm are only using whatever input variables we provided without referring to any known or labeled outcomes. So even though the 4 clustering methods, have different algorithm, there's commonality. The commonality is that they all first try to calculate similarities and then use that similarities to form clusters. So here, this is our very first attempt at it. So it's exploratory in nature. And then we just want to first to see how each method works in terms of the clusters they formed. And then we want to see how much they converge in the clustering of the careless respondents. Data used for this talk are from the National Study of Socioeconomic and Health Experiences. This study is a kind of like a methodology study. We embed a lot of experiments, and the goal is to understand mechanisms accounting for panel conditioning. We invited a sample of 8,000 registered voters in 2 different states to participate in web surveys 4 times. Each time we send them mailings, we send them emails, we send them text messages for them to participate in that. The 4th wave of data collection occurred between February to March 2023, and a total of 947 people completed the 4th data collection at a response rate of 72%. The variables we use in the clustering methods, as you can see, are the typical measures we use to evaluate data quality or identify careless respondents. The first 6 are very common measures. And the last one, like I said, we're really looking for both very high scores or very low scores on this entropy values. So if we just use each of the variables alone to identify careless respondents, on the right side, you can see the number of the percent of cases will be flagged as careless respondents. For the 4th wave of data collection, we actually embedded 2 trap questions, one at the beginning of the questionnaire and one towards the end of the questionnaire. And only 5% of our respondents failed at least one trap question. And then 25% of our respondents reported, self-reported, that they have multitasked during answering the survey interview. If we use timings, and we can flag 5% fastest respondents as speeders. And then for item 9 response rates, we use a group of 60 items that everybody is supposed to answer. And then for each individual, we calculate this person level item response rate. And if we use 5% as the cutoff value, we will be flagging 7% of respondents as careless respondents. And 8% of our respondents selected an extreme scale point to at least 50% of items that uses a response scale. And 1% of our respondents, again, selected the midpoint of the scale to at least, again, 50% of the times. And if we consider the largest 5 percentile values as too large, to indicate two ordered responses, and the smallest 5% to indicate two disordered responses, then we would be able to identify 10% of the respondents as careless respondents. So clearly here, I'm just gonna, my point here is that different indicators would identify different numbers of people as careless respondents. And different cutoff values would also lead to different percentage of respondents as careless web respondents. So let's see how the clustering methods work. The k-means clustering methods yield two clusters with about 50% of respondents in each cluster. And cluster 1 is what I labeled as careless respondents. And as you can see, if we look down at each of the rows, you can see about 1/3 of the respondents in cluster 1 self-reported as multitasking, and the same percentage is only 20% for people in cluster 2. And similarly, more people in cluster 1 were flagged as speeders, and then more of the people in cluster 2 selected an extreme skill point at least half of the point, 50% of the time. And then interestingly, the cluster 1 respondents, we have more of them selecting middle responses at least 50% of the time, and none of the cluster 2 respondents had this behavior. Now move to hierarchical clustering. This method yielded a much smaller cluster of careless respondents. Only 48 people were classified into cluster 1. And then again, looking down each of the row here, you can actually see a couple of things. More of the cluster 1 failed the trap question, and all of them were flagged as speeders because they belong to the top fasted 5%. And more of them, provided high item response rate. More of them, provided more of the extreme responses, and more of them provided more midpoint responses, and more of them having response entropy too large or too small. So again, clearly these 48 respondents have exhibited worse response behavior. DBSCAN clustering identified 98 respondents as a careless respondent. And looking at here, we see the same pattern. Half of the people in cluster 1 failed the trap question, and almost half of the people were flagged as speeders, and 13% of the people had high response rates, high item response rate, and more of them had more extreme responses, more middle responses. So again, cluster 1 people were exhibiting worse behavior, careless response behavior. The mean shift clustering actually produced even smaller cluster 1. And then again, the same pattern, you can see people in this cluster 1 had worse behaviors. More of them failed trap questions, more of them reported multitasking, and more of them had higher item response. And again, the entropy here is alarming. More of them having too large or too small of the entropy values. Okay, so now looking at the converge of the 4 clustering methods, 85% of the careless respondents were only flagged by one method, as you can see the distribution here. And 10% of the cases were flagged by 2 methods, and 5% by 3 methods, and 1 case were identified by all 4 methods. Now, if we drop the k-means results from the table, we can see more of the converging. Now, close to 50% of the cases were flagged by two methods. Specifically, they are flagged by hierarchical dbSpan or dbScan by mean shift. And again, one were flagged by all three methods. It looks like hierarchical is part of the dbScan cluster. So what did we learn? The clustering methods definitely have potential to identify careless respondents. They do yield a different number of respondents to be classified as a careless respondent. And again, more importantly, different variables are determining clusters for different methods. But there's a lot more research. Like I said, this is only the first step. There's a lot more to be done to evaluate and validate all these methods. The first question is the number of optimal clusters. Both k-means and hierarchical methods produce solutions of more than 2 clusters. So are those, are 2 clusters sufficient enough, meaningful enough, and different enough from each other? Do we need to look beyond 2 clusters? And then the next one is we're going to profile the clusters, who are in each cluster. And then the next questions would be, how can we use these clusters to inform the detection of careless respondents during data collection? And then lastly, can we predict careless respondents based on these clusters? So knowing that their cluster membership now, how can we predict their behavior in other data collection? So again, this is an open area, and we encourage more research in this area. Thank you so much. That's all.
Thank you, Ting, and thank you to all of our speakers today. This was a wonderful session. We have a few minutes for Q&A, so we invite anyone to either raise your hand if you'd like to ask a question verbally, or submit your question to the chat. Okay, it looks like we have a question from Tracy Hunt White. Thanks for the very informative presentations. I have a question for Alda on QR codes. Did you have people enter a user ID? Were they probed about it? Do you have recommendations about using QR codes for surveys where you need to enter a user ID?
Hi, thank you very much for the question. For these specific studies, for these usability evaluations, we did not use an ID that was related to the participants' number or anything like that. We would like to be able to test that technology, but mainly because that would be the main advantage, right, of QR codes, that if you have to type these alphanumeric strings, then you don't really have to if it's linked with the QR code. Unfortunately, we were not able to test that for these 2 rounds, but hopefully we can test that in the future. And definitely, the advice would be that to try to avoid having the potential respondent having to go through the burden of typing the whole website and the ID. Thank you for the question. I hope that answers.
Oh, I'm sorry. I was on mute. We have another question for Alda, who from Allison Brown, who said hacking has increased with QR codes. Did you note that issue?
No, I'm not aware really of any studies comparing whether hacking is more likely through QR codes than through any other method, or like of scamming that involves just visiting a website. So I'm not really aware of any situation like that. I can answer that question. Thank you.
Other questions for any of our speakers? Oh, I see one. Okay, I see one from Erica Yu for Ting. I am drawn to the solutions for identifying careless respondents during data collection with the hope of intervening or ending the survey to save money or sample. Do you see potential for using clustering like this during data collection, maybe providing different interventions depending on their cluster?
I definitely see the potential of using this type of clustering, during data collection, and I definitely see, Conrad and his colleagues showed that when people exhibit bad behavior, undesirable behavior, and we provided intervention, people's behavior do change, right? Do improve. So based on that, I do think there's a potential for detecting worse behavior, undesirable behavior, and provide intervention right there, telling people how we want them to answer the question. I think there's potential, but I'm not aware of any literature at this point. I think that's the next step that we want to convey. Again, this is during data collection, and then also thinking about longitudinal surveys, right? You know what happened to them last time. Moving forward, what can we do? So again, there's a lot things that can be done and should be done. Yes. So the answer is yes, but we need more research.
Okay, thank you. I see a question from Riva Denny. Question for Anwar. Are you concerned that the rise of generative AI is undermining tools or strategies for identifying bots?
Yes, definitely. That has been a concern. AI, just like anything else, can be used in a positive way or a negative way, but no one wants to misuse it. Like, just to give an example, we have a survey where certain teenagers of certain gender or background, there are certain criteria that they have to meet in order to be eligible to take a survey and get an incentive. They could just create a profile using AI, which fits in all those requirements. So now you have a perfect fit of a respondent who fits into a sample size, so they can complete the survey, and the chances of getting that incentive is a lot easier now, instead of just manually guessing it or trying to create a profile. It is concerning. It's not yet impacted as much as we had expected, but it is going to be. If you're not paying attention to this, it could have some consequences for sure.
Thank you. Are there other questions for any of our speakers today? We can probably take one more because I think the session ends around right now. I'm not seeing any more in the chat. Let's see if anyone raised their hand. Okay, going once, going twice. Okay, if there are no more questions, we can break there. I'd like to thank our 5 speakers again and
Looks like Robin has some technical issues. Thank you everyone for joining the session. We will break here.
Thank you. Have a nice day, everyone. Welcome and thank you for standing by. All participants are currently on a listen-only mode until the moderator announces a verbal Q&A period after all the speakers. Today's session is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn the call over to the moderator for this session, Aaron Hernandez. Aaron, you may begin.
Thank you, Anthony. So welcome to session 2A, Advances in Data Collection. Our first speaker is Dave Rowe. Dave Rowe is a survey methodologist and research director. He is currently the Director of Research Design and Data Services in the ICF Research Science, Survey Solutions, and Data Modernization portfolio, where he leads a team of statisticians, methodologists, developers, UX experts, analysts, and data managers with skills that touch all points of the survey data capture lifecycle. And his presentation is Implementing Custom Integrated Solutions for Efficient and Anonymous Data Collection and HIV Diagnosis Surveillance. And take it away, Dave.
Thanks, Aaron. I appreciate it. Hi, everybody. As Aaron said, I'm Dave Rowe. I want to start out actually by thanking and acknowledging my co-authors and teammates on this project, all from ICF, Joshua Jewell, Bridget Varian, Natika Dembla, Kim Etheridge, Ashley Nielsen, Sam Williams, and Jonathan English. So for today's presentation, I'm very excited to present about this really complex and unique project today. I'm really hoping that this doesn't inspire any post-lunch naps for those of you who are on the East Coast. But I'm going to be talking about our experiences working on a multi-phase study that required a customized solution that integrated multiple components. And we did that in order to keep data flowing freely and safely while meeting very strict privacy requirements. So after providing a bit of study background and high-level information on our design, I'll talk a bit about data collection and, of course, our challenges and solutions. And just as a quick disclaimer, many of these solutions are custom and proprietary. I'm going to be telling more than showing today, so I apologize in advance to anybody who is interested in wanting to see screenshots or demos of different features of the system. I won't be doing that today, but I really do encourage you to contact me after the presentation for more info. My contact information is on the last slide, and I'd be happy to have other discussions about this offline. So let's start with some study background. This is a study that we call SHIELD, and SHIELD is an acronym that stands for Surveillance of HIV-Related Service Barriers Among Individuals with Early or Late HIV Diagnoses. This is done by CDC's Division of HIV Prevention. ICF is under contract to manage the data collection for this study for CDC. DHP's mission is to rapidly detect, reduce transmission of, improve knowledge about, and ultimately prevent HIV infection and reduce HIV-related illnesses and death. The goals of this study are to collect information that will help DHP understand current gaps in HIV prevention and testing, which will ultimately allow them to inform current and future programs and interventions. And as far as our study goes, our participants, we are focused on individuals who are either at stage 0, which is early, or stage 3, which is late, of their infection at the time of diagnosis. And I want to point out here the reason why these two stages in particular are important. With stage 0, an early diagnosis suggests that testing efforts are successful, but perhaps prevention efforts are not. Whereas in stage 3, with a late diagnosis, there's an indication that there's both unsuccessful testing and diagnosis efforts. Those folks who are participating in this study are folks who have had a recent diagnosis, which for our purposes means no more than 24 months ago. So I'll talk a bit about the study design. This is a pilot study. We are working with 4 health departments right now, the states of Michigan, Louisiana, and Florida, and then the city of Houston Health Department as well. And the health departments are the first phase of a 2-stage process, or first stage. So everything that we do begins at the participating health department level. They are responsible for, first and foremost, recruiting participants using data and reports from the recently diagnosed. That is how the sample for this process is created. They then conduct a number of recruitment efforts, screening to establish eligibility, consent into the study, and registering individuals for the study. After registration, ICF manages a multi-mode interview. That's where we conduct a survey in either English or Spanish, and the participants who are registered are able to choose either an immediate transfer to our call center for a CADI interview, a scheduled phone interview, again, a scheduled CADI interview, or a self-administered web interview. So here's an overview of the data collection process. It's more of a visual of what I just explained, right? Everything up to sort of the trident on the far right side is what takes place at the health departments. Everything from recruitment all the way through gathering certain information that's needed, and then determining the interview mode, and then they are handed off to this multi-mode survey that RTI collects. And I'll talk a little bit about these system components to the left as well, because in addition to managing the data collection, we are at ICF creating the solutions that are used across both phases of the study. But here's the big challenge, in no uncertain terms and great big capital letters, right? This data that's being collected is CDC HIV surveillance data, and it's protected under the assurance of confidentiality for the National HIV Surveillance System and Surveillance Related Data, or HIV AOC. ICF will not, does not, cannot receive, manage, or store any personally identifying information, or PII. And that includes information that, when combined with other pieces of information, could become identifying information. As part of the cooperative agreements that our 4 participating health departments have with CDC, the health departments do have access to PII, and they can use it to manage participant contact, provide technical assistance to participants, etc. But what does this mean for us on the data collection side when it comes to that multi-mode survey, and really all the other aspects of data collection as well? Well, our call center can only provide inbound calling. That's the only capacity we have here. And we have to staff and be ready to schedule in a manner that allows us to support both our scheduled calls that we know are coming and immediate transfers of participants by the health departments, which could happen at any time during our operating hours. It also means, quite critically, that the standard typical outbound non-response follow-up techniques that we would use in a data collection effort, be it just a phone survey or a multi-mode survey, can't be utilized by our interviewing staff. We can't provide reminders before appointments. We can't follow up on missed appointments or late web interviews. We can't reschedule folks. We can't call back people to resume partials or follow up with the folks who have refused to try to attempt any type of conversion. So that transfer of information back to the health departments who do have access to the PII that facilitates this type of follow-up is critical for us. And it's the most important component of participation management and support. No PII is essentially the biggest challenge that we have logistically, and it shapes everything from our system design to the way we think about sharing and passing on information to how we train our partners and set them up for success with the systems that we create for them to use. So multiple solutions are required for this multi-phase project. We need a centralized solution for our health department staff to be able to recruit, collect information, and manage cases. We have to assign customized IDs for privacy. We have to be able to instantly pass data from registration to the web or phone survey to make sure that respondent preferences are captured, like obviously mode, routing, certain preloaded pieces of information that drive routing and fills, language, and so on and so forth. We have to have a flexible appointment scheduling system. We need to protect inbound caller information at every phase of the process. We also have to provide post-paid incentives, and we need to do it in an anonymous way. And then we have to develop custom reports to facilitate case management. And again, it goes back to how are we creating the best feedback loop we can for the health departments that are participating. So I'll talk a little bit first about that centralized web-based solution that we created for health department staff. And this is separate from the multi-mode interviews, and it's only accessed by the health departments. It registers it allows them to register participants for the next stage of the study. It assigns anonymous case IDs that are used to track participants across the study, but isn't linkable in any way to any PII within ICF's part of the data collection systems. It captures participant level information in a general information, not PII, right? I want to just continually restate that. But there are things that are needed for the survey itself. Preferences like language, whether or not they want to do the web versus the phone. Are they being transferred or setting an appointment? We even have an option for those who are doing phone appointments to tell the health departments when and how they want a reminder call so that they remember to call us. Because again, remember, we don't have our scheduler working. We can't make those outbound calls to the CADI participants. And it facilitates all the things that you need to actually do the data collection, right? So scheduling appointments in a custom calendaring system, giving out the instructions and link to the web survey that are needed. And then again, really important component of managing and supporting participants is allowing health departments to re-access cases using that ID that we assign to each case so that they can follow up and reschedule missed appointments or switch mode preference at any time. We have folks who start on the web and say, you know what, I want to talk to somebody about this, or vice versa. And regardless of where they are in the interview phase, if they break off, they can switch modes and pick back up. It also allows the health departments an opportunity to document refusals or decisions to withdraw. So I'll talk a little bit about the call center management system. This is a fully integrated system that is visible and works and operates within the health department's environment and also our call center. Appointment information gets fed to the call center and back to the health departments as well. It's populated with essentially all the appointment slots that we have available for the entire contract year, and it allows for real-time changes and time slot adjustments. So that works two ways, right? First of all, it allows picking appointments and getting them scheduled and making sure that they disappear from the user interface view when they're scheduled. But also it allows our call center to go in and say, if we ever know that there's going to be an hour or two slot of network downtime, or multiple interviewers are ill and not working, if there's anything that could happen that could affect our availability, we can target specific days, time slots during the day, and essentially pull appointments back so that they're not used by the health departments. It gives the health departments visibility into potentially overbooked times, which is great because it helps all of us as a team facilitate conversations about surge capacity and when we need to schedule or even bring in and train extra interviewers based on what's going on. It captures scheduled date and time, provides the health department with information to give to respondents, the toll-free number to call in, et cetera. And again, as I said, it's fed in real time to the call center. They have reports that they can use to know when cases are calling in so that we make sure that we have staff available. And it allows health department staff also to cancel or reschedule appointments. So we've moved past the registration and the appointment scheduling process. Now thinking about our inbound callers for the telephone survey, how are we protecting them? Well, again, our inbound system is tied directly to our call center team. All the inbound calls that come in are hashed or masked upon transfer or connection. Our agents can't see the caller ID or the phone number for the caller. There's nothing that shows up. Our logs are cleared immediately to ensure that nothing's maintained in our system. And we start the process when folks call in with an IVR script that requests that the caller enter their unique ID. It also provides, just via the script, reminders about the privacy and confidentiality of the study, reminding them that when they do connect to an interviewer, they should not give their name or any other personal identifying information. And this system facilitates a pop screen, essentially, where our interviewer will connect and start to discuss, welcome the participant to the study and discuss next steps and inform consent for the survey. But the CADI interview that's directly linked to that interview that participant is ready. It's linked to that ID, and it's also language ready. So everything gets passed through the system from registration so that it's ready to go once the call is connected. We also have to work with real-time and immediate incentive distribution. So this is built directly into our survey platform. We capture a host of metadata in a SQL database that ties the distributed incentive to the participant ID along with the timestamp. And we have multiple things built in for fraud protection. And again, a lot of that is based on project IDs. Valid IDs that don't have a previously assigned gift code get a code assigned when they cross that threshold in the interview. If for some reason somebody has been assigned a code and they get back into the interview and they loop through that again, the system is going to look at what gift codes have already been assigned and what ID we're working with. And if it's an ID that's already gotten a gift code, it's not going to get a new gift code. It's essentially going to, the system is going to return that previously distributed gift code over and over again to make sure that there is only one. And it's tied to other metadata for identification and research of suspicious activity as we manage our data. So finally, I want to talk about our customized reports for case management. We have created a host of reports, both for our call center and most importantly for the health departments that we're working with. Again, because we don't have PII, these are critical to giving the health departments the info that they need to manage participants and follow up and help problem solve. Registration, full case history allows us to track changes in mode, completes, refusals. Upcoming appointments reflect a lot of what's in our appointment system that I already talked about. Web invites, reminders, different aspects of non-response follow-up, screen outs just in case anyone answers questions in the survey differently than they did at registration, so that the health departments can follow up with folks who, for example, are underage or report that they're underage during the survey phase or refuse to consent to the survey. And then incentives. If folks have problems with their incentive codes, it allows our health departments to contact them, work with them, and they can see the code that was assigned to each ID in the reports that they have to make sure that people have recorded it correctly and are using it correctly. So that is it for the customized components of this study. I appreciate your time today, and I welcome any questions at the end. If you're interested in how these reports came about and how we work with our partners in order to actually conduct the work that we're doing and manage all the things that go along with the system components, my colleague Bridget Varian is going to be presenting in session 3B at 2:45, and she's going to focus on training and supporting our partners at the health department. So do encourage you to check that out if you can. Here's my contact information along with Josh Dool, our Senior Survey Solutions Lead. Feel free to get in touch with us with any questions at any time, and thank you very much.
Thank you, Dave. So before I introduce the next speaker, and while they pull up their slides, I did just want to point out something Anthony put in the chat. Thank you very much. There will be an opportunity to ask questions at the end of the presentations, but in the meantime, you can type any of your questions in the chat for now. Just make sure that in the to drop down, you have everyone selected so that we can all see your questions, and I'll go through them at the end during the question and answer portion. And you'll also have a chance to ask questions verbally at that time. So now I'm going to introduce our next speakers. Kristen Flaherty. She is a senior project manager at ICF. She manages a project under which ICF collects and manages data for 2 large HIV surveillance studies. Kristen has been at ICF for almost 10 years with a background in data management, project management, and SaaS programming. And then Nicole Gonzalez is a senior data manager who leads the various data efforts for those 2 large HIV surveillance studies. She is an advanced SaaS programmer with a background in epidemiology, statistical analysis, and data management. And they are going to be presenting modernization of an HIV data coordinating center.
All right, can everyone hear me and see me okay?
You're good.
Okay, thank you. All right, so good afternoon, everyone. Today, my colleague Nicole and I are going to present on a current initiative to modernize the data collection efforts, data management processes, and overall data coordinating center for a project here that so collects HIV data. So a little bit of background before we get started. I'm sure many of you are familiar with the data modernization initiatives within the federal government and state health departments to produce actionable data faster. So in order to accomplish that goal, there's a need to modernize and streamline a lot of processes. And emphasis is being put on creating more replicable and automated methods. So a lot of projects across a lot of disciplines are being revamped and rebuilt to be more sustainable over time. Today, we're going to talk to you about our experience modernizing a project at ICF that supports 2 large HIV surveillance systems. So for the past about 15 years, ICF has been the acting data coordinating center for these projects. Historically, the work was shared between multiple contracts. There were 2 different contracts for data collection components, and then our contract for data processing, cleaning, and coordinating. So data was coming to ICF from multiple sources on various timelines. Having those multiple contractors did make the process a bit inefficient. So then in 2021, all the work was consolidated into one contract, and ICF was very happy to win that bid because this was the first step to really modernizing and streamlining the effort. Under this new system, we're creating a system that we like to call a web-based integrated surveillance management system. As part of the modernization, ICF is working with the client on a phased migration to the cloud. So by 2026, we plan to have all parts of this data collection system in the cloud, but right now the project server environments do exist in 2 settings, and this will be important to understand later regarding data movement. So we stood up the data collection instruments in a client-managed Azure cloud environment. So that's the dark blue cloud shape here with the number 1. And then we also host our Voxco data collection software, a SQL database, and SAS software for data processing. And then we also still maintain an ICF managed on-premise data center in that light blue oval shape with the number 2. And here we host a web server that backs our online data portal, another SQL database, and another SAS software server. And then data collectors also use various desktop apps for tracking data as well. So one of the most significant changes in the last few years is that ICF now programs and maintains the data collection instruments using Voxco software. This project uses its own instance of software that is hosted in a cloud environment, and data collection is completely online. So this is a big change from the previous offline desktop app software that was being used. We have a total of 4 data collection instruments under this project, and each has a mock version for training and practicing as well. Understanding the benefits of using Voxco and online data collection is important to understanding the changes we were able to make to the data management strategy, because Voxco allows for better validations during data entry and therefore less need for data cleaning later. So some examples of the data validations are that we can check dates entered between 2 different instruments in real time. We can also check key demographic variables such as gender and date of birth that are entered in 2 different instruments. We can pipe data from one instrument to another, and we can gatekeep access to an instrument until a certain point in another instrument's reached. And I mean, all of these various Voxco validations result in less missing data or conflicting data. Data is also synced or saved instantly to SQL databases as it's entered, which eliminates the need for project areas to manually encrypt and send us their interview files. And this eliminates the possibility of lost or corrupted interview files, which was a problem that we had in the past. We also have a couple different strategic ways to manage sample and access to the surveys. Some of our instruments use a preloaded sample that contains participant IDs or PAR IDs. We preload those and use them as the survey entry key. Those IDs are locked after use to prevent duplicates as well. Another one of the instruments we have, for example, doesn't use a loaded sample, but our team developed an access management plan that essentially creates a unique identifier for each interview record using the project area ID and a survey ID as it's being entered that can later be used for re-entry and to manage instrument access.
So now I'll be talking a little about the data and how the implementation of Voxco has changed our typical processing. So historically, project areas collecting the data would conduct interviews using an offline desktop application that really required a high level of effort on their part to manage all of the individual interview files, and also required manual encryption and submission. This sometimes resulted in lost or corrupted interview files due to various user error issues, and sometimes submissions were not received correctly. ICF would receive these submissions from each site on a monthly basis. And then for data managers on the receiving end, this was all a manual process of downloading, decrypting, exporting the interviews into XML files, and then converting into a SAS data set. And so we would do that over and over for each site. And because this was a monthly submission, our data management reports were only being updated once every month. So moving to a web-based system like Voxco, we can receive data more frequently and more efficiently. Each night we get data from all sites through an automated export and data transfer. So already from the start, we are cutting out a lot of the manual steps that I previously described by just getting one SAS data set with all site data in it. So on to the next slide. In order to achieve this fully automated process, we first need to export the data from Voxco, which is done through a PowerShell script that runs on a scheduler and calls a series of SAS programs. Part of the SAS code here includes a web API that helps move the data from the client cloud environment to the DCC server where the processing is done. So on the server side, we have a Python program that uses a package called SASPy. And this program watches for the incoming zip file and will check the file name, the contents of the file, just to make sure everything coming in is what we would expect, and then calls another SAS program, which is our typical master processing program, to clean and process the data, run data quality checks, and upload the data to the user portal where project areas can view their data and reports. So for these first two bullets, the first set of SAS programs in the cloud and the Python script, these were brand new developments to accommodate the new contract won in 2021. As opposed to the third bullet being our master processing program, which was a need that existed for the last decade since we first started working with this client. So this was a set of well-established code that we then, the data managers had to make various updates to. So primarily what was different, as I spoke to before, now we're processing a data set with all site data in it instead of several site-specific data sets. So we removed several loops and references to site, and the code was made much more simple and streamlined in this way. Also, because we are receiving one all-site data set each day, that did change a lot of our folder structure, and it increased the amount of incoming data. So we added macros to move and archive data sets, and also to purge data in our archive folders that were older than 30 days in order to clear up space. And on the next slide, moving on to several advantages that this daily automated processing has brought. So certainly it's more efficient. A data manager doesn't need to sit there and go through all of these steps in order to process the data. Also, with data coming in every day, we are populating our portal data management reports on a daily basis. And this is a huge improvement from our previous monthly reports, and really allows project areas to go and address potential errors and data quality issues much faster and much earlier in the cycle. Also in the portal, project areas can view their data in the data viewer. And again, that is updated every day. So after completing an interview, sites are able to see that processed data very quickly. And as part of our code updates, we included a summary PDF of internal checks that kind of acts as a one-stop shop of potential issues or other things that we want to keep an eye on in processing. So we'll have text print out if there are errors or warnings in the logs, and it also checks for things like data structure, duplicates, and any other critical missing info that may appear. So on the next slide, Moving on from the advantages, we of course faced several challenges as well. In particular, our medical record abstraction instrument is an especially massive and complex instrument with various different forms. And having all of that in the cloud, we at first had trouble with load times, slowness, glitchiness, and general unpredictable behavior. So our team has worked very hard to optimize the instrument and decrease load times as much as possible. We've worked closely with the Voxco team as well to troubleshoot any other unexplained behavior. And since the instrument was first launched mid-2023, it has gone through several updates to improve user experience greatly. And operating in the client's cloud also proved to have its challenges, as we were very reliant on external staff that worked with that environment, as well as security management staff. It took us quite some time to set up our full automation due to various access issues and getting approval for necessary software in the client cloud that we needed to run the web API and other tasks. Management of our help desk feature has also become more difficult as we've gotten an increased amount of tickets regarding Voxco issues or other security access issues that we often have to forward to other parties for resolution. Another challenge we ran into was distinguishing the default Voxco dispositions with the project-defined details of a complete record. It was necessary for us to discuss with our client prior to launch to define what records should and should not be pulled into processing. So for one example, in one of our studies, if the record makes it past the demographics section in the core interview, that is when it will be pulled into our processing. And that's something we continue to monitor by generating a partially complete data report, which we send to the client each month. And lastly, another challenge we faced was troubleshooting around what we call dummy IDs. So a dummy ID is a survey entry ID that can be used if a particular ID is locked out due to prior use. So this ties in with the sample management that Kristen mentioned at the beginning of our presentation. And in Voxco, there's a validation flag that checks survey response for individual ID against the ID used for entry. It is a soft validation in case there was user error with the survey entry ID, but this sometimes caused confusion for users in the case of dummy IDs where that individual ID value should be changed to generate a corrected ID, but every so often we would get an individual ID that matched the dummy ID and in the end caused an invalid ID that didn't match with our any in our preloaded sample. Of course, this was easily diminished by training project areas further. And additionally, if a user went through a whole interview, then realized afterward that the ID was incorrect, historically our usual process to correct an ID was to have project areas enter the corrected value in a data error log in the portal, which was then applied during processing in the SAS server. However, due to the Voxco linkage of the interview and medical record abstraction instrument, that method was no longer sufficient. We instead have to change that ID value in the raw interview Voxco data in the backend in order to correctly activate that corresponding medical record abstraction ID. So those were just a couple things that we didn't originally anticipate when setting up that specific sample management system. And I'm going to hand it off to Kristen again to wrap us up.
All right. So as with any major change to a project data collection process, we've gotten a lot of feedback from our client and end users, and a good chunk of it's been positive as well. A lot of our data collectors find the new systems easy to use. They appreciate not having to manage individual interview files, and they appreciate the connections between the instruments. And our client has also recognized that we've done a tremendous amount of new development, programming, and testing for this modernization effort. They also really like that more data is available, such as consent and recruitment, which the clients found useful. We've been able to develop several new reports that show interview time duration, screen out, and more info for partially complete records. Earlier, I briefly mentioned that we are working through a phased migration to the cloud. So we do expect to be fully in the cloud by late 2025, meaning we can decommission all hardware and stop maintaining our on-prem data center for this project. We're really excited about the added efficiency of operating in one environment and not needing to move the data between the two environments. So, and this will provide a cost saving as well. Once we're settled in the cloud, we're also planning to build a data warehouse to house all the data in a one-stop shop with dashboarding and reporting capabilities. And this is our contact information if anyone wants to reach out later, and then we'd be happy to take questions at the end.
Great, thank you so much. It's time for our next speaker, Erica Harrell. She is a statistician in the Victimization Statistics Unit at the Bureau of Justice Statistics. Let me make my screen a little more readable. While at BJS, she has worked primarily with the National Crime Victimization Survey and has written on a variety of topics, including crime against persons with disabilities, workplace violence, and identity theft. She was also part of the team that created the National Crime Victimization Survey Data Dashboard, or INDASH. Dr. Harrell was the lead author of Indicators of Workplace Violence 2019, a publication with contributions from 3 federal agencies on issues concerning workplace violence. She was also the author of Carjacking Victimization, 1995 to 2021, the first publication in the new Just the Stats series offered by BJS. She's also a member of the Interagency Subcommittee on American Community Survey Disability Questions. She holds a bachelor's degree in criminal justice from Tennessee State University and a master's degree and PhD in criminology from the University of Delaware. And she will be telling us about assessing and redesigning the identity theft supplement. And, oh, I'm sorry, I need to scroll down because we're also going to be hearing from Alexandra Thompson, who is a statistician in the Victimization Statistics Unit at the Bureau of Justice Statistics. Ms. Thompson's portfolio of work currently focuses on school crime, youth victimizations, hate crime, and identity theft. She has co-authored various BJS statistical reports, including Criminal Victimization 2022, Hate Crime Victimization 2005 through 2019, and Victims of Identity Theft 2021. Ms. Thompson holds a BS in Statistics and Economics from the George Washington University. Okay, and now I'm done.
Thanks, Erin. I want to thank everyone for being here today. Myself and Lexi will be talking about assessing and redesigning the Identity Theft Supplement, which is a supplement to the main survey that we work on, the National Crime Victimization Survey, or the NCVS. An agenda for the presentation. First, we're going to go do a short overview of the NCVS and the Identity Theft Supplement, or ITS. We're going to talk about an instrument redesign of the ITS and discuss statistical findings from the 2021 ITS, which collected data using that redesigned instrument. The NCVS has been ongoing since 1973. We just celebrated 50 years last year. The NCVS is administered by interviewers from the U.S. Census Bureau to a nationally representative sample of households, with everyone aged 12 and over in a sampled household being interviewed. Persons are asked about the frequency and characteristics and consequences of criminal victimization that occurred in the past 6 months. The NCVS currently has 5 rotating supplements: school crime, stalking, financial fraud, police public contact, and identity theft, which is what we'll be talking about today. The ITS has been administered 6 times. Unlike the core NCVS, where data is constantly being collected, the ITS has data that's only collected for a 6-month period, usually the first or second half of the year. It collects person-level data so that we can generate person-level prevalence of identity theft, both past year and lifetime. And unlike the core NCVS, where we ask questions of people age 12 and over, the ITS is limited to people age 16 and over. The current ITS questionnaire from the 2021 ITS has several sections. First off, there's a screening section which asks all respondents about the types of identity theft that they had experienced both during their entire lifetime and in the past year. If they stated that they had experienced identity theft in the past year, then they're asked about the type of identity theft they experienced in the most recent incident. Focusing on that most recent incident, we asked victims about how and when the identity theft was discovered, their response to it in terms of contacting organizations such as law enforcement, credit card companies, credit bureaus. And we also asked about the emotional and financial impact on the victim. And also we asked about offender information, the identity of the victim, and the method that was used to access their personal information. And all respondents, both victims and non-victims, are asked about preventative behaviors that they used in the past year to prevent identity theft, including shredding of financial documents. And they also are, all respondents are also asked if their personal information has been exposed during a data breach and if they were notified about it. Turning to the ITS instrument redesign. Back in the beginning of 2019, BJS, the Bureau of Justice Statistics, began to update the 2018 ITS questionnaire in preparation for the 2020 ITS. Normally, it was given once every other year. This update involves BJS making wording changes to several questions and the removal of questions that dealt with the frequency of online shopping and with knowledge of receiving a free credit report each year. The Census Bureau provided an expert review of the ITS questionnaire through its Center for Behavioral Survey Methods. In June of 2019, BJS initiated meetings regarding methodological concerns about the ITS. Analysis by BJS staff showed that some respondents reported that their most recent incident of ID theft occurred during the past year, but they also reported that that same incident was discovered prior to the past year, and BJS believed there may have been some telescoping involved. At the end of 2019, BJS contracted with RTI International to conduct research on the ITS screener to address these concerns. The research was in 4 parts, one being the analysis of state identity theft laws, secondary data analysis of previous ITS data, cognitive interviewing, and an online pilot test. The ITS was taken off its 2-year rotation, and it was postponed until 2021. The purpose of the legal analysis was to see if the definition of identity theft used in the 2018 ITS was reflected in state laws against identity theft. The definition of identity theft that was used for the 2018 ITS was the misuse or attempted misuse of an existing account, or the misuse or attempted misuse of personal information to open a new account, or for other fraudulent purposes, such as getting medical care or applying for a job. The analysis looked at 4 areas of law: how personally identifiable information, or PII, was defined, how PII was misused, the severity of the punishments specified in the laws, and the statute of limitations for charging offenders. The legal analysis searched several databases, including databases from FindLaw and LexisNexis. It found that the definition from the 2018 ITS covered a wide range of acts that fell within the legal definitions of most of the laws that were being examined, and could be its definition could be modified to fit a specific state's laws. And based on this, no change was recommended to the BJS definition of identity theft based on that legal analysis. But as Lexi will we'll talk about other research that was done that did cause change to aspects of the ITS. So I'll turn it over to Lexi.
Thanks, Erica. We can go to the next slide. Thanks. Yeah, so as Erica mentioned, we did a secondary data analysis on the ITS instrument. So the laws and the definition of identity theft have been covered, but this analysis focuses more on the ITS instrument and addressing those methodological concerns that Erica talked about earlier. So we wanted to examine three potential issues within the ITS instrument. The first being the reference point being used for determining whether an incident is or is not in the reference period. Erica mentioned that there's a date of first discovery for instance, but there also is a most recent date for when an incident occurred or when information was breached. So we wanted to look into that, as well as the potential for respondents to telescope incidents into the reference period, as well, that Erica mentioned earlier. And then we also wanted to examine the inclusion of attempted incidents in the definition of identity theft, since the 2018 instrument and previous iterations included both attempted and completed incidents of identity theft. So a quantitative analysis was conducted of data from the 2008, 2014, 2016, and 2018 ITS. Next slide, please. From that secondary analysis, we found that most identity theft victims could provide dates as reference points within when they were being interviewed for the ITS, both the date of first discovery and the date of the most recent incident. And it was hard to find conclusive evidence that respondents were telescoping incidents into the 1-year reference period. And the other result was that respondents were having difficulty separating attempted and completed identity theft incidents. Therefore, from those results, we had some recommendations. The first recommendation was to continue with the same reference points and ask for the date of most recent incident. A dual reference period was also implemented, first asking about whether that identity theft had been experienced at any point in the respondent's lifetime, and then asking next about the past year. And this was done to reduce possible telescoping. And the last recommendation was to exclude attempted identity theft and only talk about completed incidents. Next slide. So after a draft screener was completed, we also wanted to perform cognitive testing to make sure that these new screener questions were being understood as intended. And so to do that, 27 virtual interviews were completed with adults, with the interviewers, probing them about specific questions and how they were understanding them and what they thought of the questions. And from the results, we found overall there was not a ton of difficulty in understanding the new questions, but there was a bit of difficulty in some areas. For example, there was some difficulty in understanding questions around the misuse of existing credit card and bank accounts. Sometimes people confusing one type for the other. As well, there was some difficulty in understanding or in the asking of the year and the month for the most recent incident, and then also some difficulty classifying misuse of social media accounts. Next slide, please. So based on these findings from cognitive testing, the language was updated based on feedback from respondents, such as adding in more clear examples and language to help clarify the questions that were being asked. But it was also important to do a larger scale test about how to help illuminate how these data or these questionnaires were going to perform in the field. And so there was a pilot test that was implemented with 3 versions of the ITS screener with certain modifications to help isolate different effects from different changes. So the first version of the questionnaire was kind of the previous instrument that was being used, the 2018 ITS questionnaire. The second version was this draft questionnaire that we've been talking about, and all this research has been going into with the modifications from the cognitive testing. And then version 3 was most similar to version 1, otherwise known as the 2018 ITS, but the main modification here was that attempted incidents were excluded, whereas in version 1, both attempted and completed are included. And there were a couple different modes as well with the survey, which is detailed in a report that we'll talk about at the very end. And between the pilot, all the different versions and the pilot test, there were about 31,000 adult respondents. Next slide. From this pilot test, we found that version 2 resulted in the lowest prevalence of identity theft and also appeared to be the best control for telescoping among the 3 versions. Lowest doesn't always mean best, but based on the other factors, we thought it was the best instrument in terms of controlling all these different factors. It was found that respondents appeared to understand the concepts presented, such as dating the most recent occurrence of identity theft reported in the past year and other areas. And so it was recommended that version 2 be used as the screener for the 2021 ITS questionnaire. Next slide. To review, so these are the changes from the 2018 ITS questionnaire to the 2021 ITS screener, which is, again, is version 2 from the pilot test. So attempted incidents of identity theft are now excluded from the ITS, whereas previously it was both attempted and completed. There's now this dual reference period, first asking about if a type of identity theft has, or if the victim has experienced that type of identity theft anytime in their lifetime, and then within the past year. This is done for each type. Respondents are asked to give the month and the year of the most recent occurrence, whereas before it was more so based on date of first discovery. And there is now a separate screener question for the misuse of existing email and social media accounts, where that was bundled into other types of identity theft previously. And so the 2021 ITS was administered from July to December of 2021 with this redesigned screener. Next slide. Eric and I both worked on victims of identity theft 2021, a BGS report that was published in October of 2023. So I'll go over some high-level findings from the report here. Next slide. In 2021, we estimated that 9% of persons aged 16 or older were victims of identity theft in the past 12 months. And you can see we cover credit card, bank account, email, social media, or misuse of other types of existing accounts. And then we also cover misuse of personal information to open a new account and misuse of personal information for other fraudulent purposes. Next slide. When looking specifically at victims of identity theft, most of our respondents are victims of some type of misuse of a single existing account. That accounts for, I think, about 78% of our respondents who are victims of identity theft, with the most being misuse of an existing credit card account. But also 14% of our respondents were victims of multiple types of identity theft in 2021. Next slide. There's some other findings in the report, but this is just scratching the surface. We have a lot of great information in the report, such as information on total dollar value lost from these incidents. We found that about 59% of identity thefts had financial losses of $1 or more, totaling an estimated $16.4 billion in 2021. We also found that about 10% of victims were severely distressed because of the incident, and most identity theft victims spent 1 day or less resolving associated financial or credit problems. And then looking at reporting to police or reporting to other agencies, about 7% of victims reported the incident to the police, but 67% reported the incident to a credit card company or bank. And then about 1 in 5 persons experienced identity theft in their lifetime. So the previous stats, we were talking about the last year, but about 1 in 5 people have been victims in 2020, but by the time of 2021. Next slide. These are links to both the report Eric and I wrote talking about the data findings. We also have a third-party report that goes into much more detail about the redesign process, the cognitive testing, the pilot test. And then if you would like to analyze the data yourself and learn more about identity theft that way, there's also a public use data file available online, free for downloading. Next slide. We also have some fun infographics on the DJS website, both detailing some high-level findings we discussed here, but also a little information on what each of these types of identity theft mean. Next slide. Thank you so much for attending the presentation. Eric and I are happy to answer questions at the end, but also here are our emails in case you have any questions and would like to talk to us afterwards. Thanks.
Thank you. I'll go ahead and introduce the next speaker. Speakers. Next, we have Daniel Kiever, a research programmer analyst, has been with RTI since 1988 and has over 20 years of experience in optical data processing, including form design, development, optical recognition of data, dataset development, and the electronic archiving of image files. He serves as Technology Practice Area's Senior Technical Advisor for Teleform, the optical scanning software used by RTI. He has numerous Teleform templates for multiple projects using techniques he's developed, making the forms match the Word version of the surveys. In addition, he has created many existing forms from already printed surveys, programmed those templates, and tested them until Teleform read them appropriately. And Ansu Koshi is the research computer programmer who has experience in survey software development using different applications and languages. She works on computer-assisted telephone interview, computer-assisted personal interview, and paper survey projects using software like Voxco, Blaze, Hatteras, and web-based survey system and Teleform. And Maurice Martin is a research computer programmer who develops case management systems to track incoming data and outgoing tasks with sample members. They design, develop, and support paper-based data collection using Teleform. Maurice Martin is experienced in SQL Server for control system development and Teleform for paper-based surveys, and they will be presenting Teleform enhancements for survey research.
Hi everyone, thank you for joining us today. I'm Ansa Koshi from RTI International and will be presenting along with Daniel Keever and co-author Maurice Martin, who is also helping us today with a slideshow presentation. This presentation will describe how we enhanced the Teleform system by adding new features. In addition to meeting our clients' specifications and requirements with these added features, they improved data quality and data management. This was all accomplished through Teleform's upgraded scripting API. Here is a brief overview for those of you who do not know Teleform. The Teleform system is used to extract data from paper and electronic surveys. The four main modules are the Designer, which is used to build forms, the Scan Station, which scans in batches of returned surveys and creates their images. The Reader module then evaluates these images. And finally, we have the Verifier, which is the interface, allowing the operator to check and correct any information not evaluated with sufficient confidence level. Continuing with a brief overview of Teleform, here are Teleform's main data capture fields. Q1 shows a choice field, which are radio buttons used for single responses. It can also be checkboxes, which are commonly used for multiple responses. Q2 is a constraint print field, typically used to record numeric values. And your favorite coffee flavor question is a capture zone for open-ended responses like other specify and addresses. So the challenges we faced and the solutions we came up with are what I'm going to briefly touch on here. We were presented with client requirements and specifications beyond the scope of the out-of-box Teleform software. For example, clients wanted to distinguish between a question intentionally left blank and a blank caused because the respondent chose more than one response for a question which only allowed one choice. Our solution was to make enhancements by adding features to meet those requirements. These enhancements also improved our data quality, maintaining client satisfaction, and data management improves efficiency and lowered costs. Next, I'm going to turn it over to Daniel Keever, who will give more details about our main enhancements.
Thanks, Ansu. The first enhancement is what we call too many marks. It produces a file that lets the statistician know that the respondent answered this question, but chose more than one answer to a single response question. Why is this needed? Teleform only allows values programmed in the answer set. For example, if you had a yes-no question with 1 equal yes and 2 equal no, the result could only be blank, 1 or 2. Next, we have enhanced verification. Its main feature is that all blank choice fields will be verified in case the respondent marks outside the bubble. Why is this needed? Well, respondents don't always follow instructions. Instead of the normal way to verify data with only one operator, double verification has two operators to ensure data quality. An extra operator ensures the cleanest possible data since all fields are checked twice independently. However, some projects don't want double verification, so this is an optional feature. Meanwhile, the audit trail keeps record of any changes made by those two operators. It checks for discrepancies between the printed survey and the answers in the data set. And for ease of use, we modified the provided export script that only created comma delimited data sets to include SQL Server in our data exports. We also added data encryption, which protects respondents' social security numbers, for example, or other personally identifying information. This is a screenshot from the verifier. The Teleform Reader module flagged question 1 as a multiple response to a single response question. The verifier stopped here to allow the operator to determine the correct response. Teleform thinks yes is the answer. The reader usually will pick the bubble that's most filled in. The operator looks at the image and tries to determine which answer the respondent meant to mark. However, in this case, the operator cannot tell which answer is correct, so they are instructed to clear the answer, and when they do that, a window pops up. The operator checks the box indicating it was indeed a multiple response and fills in the check boxes with the answers the respondents chose. This information is written to a Too Many Marks dataset and to a SQL table. The resulting table is sent to the statisticians along with the exported datasets. Here's an example of enhanced verification. The reader does not detect a mark for question 3 because the respondent circled the answer instead of filling in the bubble. Without our script, Teleform will record this answer as blank. Our script checks for any blank choice fields and changes their field status codes to allow an operator to verify if they are actually blank or contain data. If not blank, the operator selects the answer as the image indicates. This is more efficient and reliable than depending on an operator to check each choice field from a field list in the verifier module. The side panel shows an example of a field list with lots of blanks. How does Teleform system handle processing of surveys? Well, the standard way is one scans in the return surveys in batches, creating images for the reader module, which evaluates the data programmed, the choice fields, the constrained print, and the capture zones on those images. Then the operator verifies the resulting data from the reader, correcting any data entry fields that were not evaluated with sufficient confidence. The operator also keys information from any capture zones. And finally, the data is exported. All this is done by one operator. Double verification. Our enhancements introduce a second operator. The first 3 steps are the same. The surveys are scanned, the reader evaluates the program fields, and the first operator verifies the surveys by resolving all the fields flagged in the reader, such as too many marks, constrained print fields, capture zones, and reviewing blank choice fields. By the way, in the designer, we program constrained print fields to be always reviewed for data quality. The second operator is responsible for rekeying capture zones and checking any choice fields that were changed by the first operator. We leveraged Teleform's data review process and expanded it to facilitate the rekeying of constrained print fields by the second operator and the final processing of the batch of surveys. The data is exported as before. These extra steps have enhanced the already high data quality from the out-of-the-box Teleform system, since every field is checked twice by 2 different operators. Soon after we added the Too Many Marks feature, we created an audit trail to record any changes made during verification. This file helps resolve discrepancies between values marked on a survey copy and recorded in a dataset. The log shows any data that has been changed from its previous value, either made by the reader or the first operator. For example, the arrows point out changes made to individual data points during the verification process. The top arrow points to our Too Many Marks example, with the final data now blank. The middle arrow points to our enhanced verification, with the circled value, now it's correctly recorded. And the bottom arrow shows the before and after of a key field in a capture zone. The double verification and audit trail also led to the creation of individual data sets for each operator. The data sets are collected at the end of each operator's verification process. One use of these files is to create error reports for their supervisors to monitor their quality of keying. And to take it back nearly to the beginning, we added script to collect data directly from the reader, but before verification is started. So we have data sets collected through every phase of the Teleform process. Now, data export. A common data export format is a comma delimited data set. It is a very flexible and easy to use format. This slide shows the CSV setup screen from one of Teleform's exports. Teleform comes with an example export script using this format. It started out as basic script, then VBA, and now COM scripting. We took that COM scripting code and enhanced the system to export data easily into SQL Server tables and comma delimited data sets. There are 3 SQL Server tables created for each template: a data table, a batch information table, and a meta table that has the variable name, variable type, and variable length. So it's easy to create SAS input and format statements from this table. We also have added the option to encrypt values in either export method one chooses. Encryption is generally done at a cell level. Thus, all survey answers, especially personal information, are protected. These and other additions we've made to Teleform have improved data quality, efficiency, and data management while meeting our clients' needs and lowering costs. Thank you very much for attending this presentation. There's our contact information, and we'll be glad to answer questions following the last session.
Great, thank you. So we have our final presentation. We're starting to run out of time, so if you do have questions, please put them in the chat so that our speakers have a chance to see them. And our final speaker, if my laptop will cooperate, is Jack Peter Leeds, a human resource specialist within the Human Capital Strategy and Accountability Office of the U.S. Census Bureau, where he supports studies of human capital initiatives with a focus on quantitative methodology. He also teaches graduate statistic courses at the University of Maryland and George Mason University, and he will be presenting Barriers to the Use of AI in Government. And you might still be muted because we're not able to hear you at this time. We are still not able to hear you. You might have to allow WebEx to use your microphone.
You know, do you hear us? Give us a thumbs up. Well, we don't hear you. So what you could do is on the bottom of your screen next to the mute button, click that down arrow and choose a different microphone.
Testing.
Oh, I hear you. Talk again.
Testing. 1, 2.
Yeah, we hear you, but it's very low. So if you want to adjust the microphone setting, if you go into the audio, pick up that microphone volume. Can't hear you, barely.
Testing.
Yeah, that's better now. Good. You're good now. So you could go ahead and share again and go to slideshow mode.
Okay, when I did that, it disappeared. Can you run my slideshow for me?
Yes, I can do that. Let's pull that up. Are you able to see it?
No.
Click the share button once more, Aaron. There you go. It's coming on now. Yep, just go into slideshow mode. There we go. Looks good. You just have to cue her, Peter, to go to the next slide.
Technical difficulties. Thank you for helping me out. Okay, yeah, we're going to be discussing barriers to the use of artificial intelligence in government. My name is Jack Peter Leeds. I work for U.S. Census Bureau. This presentation was assisted by Troy Brightson and Canna Beckles, who contributed to it. And yeah, let's proceed. Next slide. The agenda, I'm going to discuss some relevant executive orders that are pertinent to using AI in government. Then we're going to go to the requirement for FedRAMP certification, some ethical challenges, discuss PII and privacy concerns that might be obstructions, need for transparency in artificial intelligence, and what a paradox that might represent. I'm a psychologist by training. I have a PhD in industrial organizational psychology, so I'm very interested in psychological aspects to the obstacles, including fears of job replacement, depersonalization, fear of AI itself, of course, plagiarism, AI content detection, and finally, being government bureaucracy is another challenge. So next slide. Executive orders, the first one, next slide. We're going to be looking at 14028, requiring improving national security, national cybersecurity. There were a couple interesting pieces of this this executive order. One was the need for zero trust architecture, the idea that government is not prepared to trust AI platforms without evidence that they're trustworthy. This requirement is for least privilege access, meaning only individuals with a need to know and a need to perform analysis should have access to the particular system, in this case AI. Micro segmentation, requiring that small, secure areas be set apart such that there are stovepipes preventing individuals from spreading information or perhaps contagion. So that's another requirement, and the requirement of continuous monitoring and validation of our IT systems. Integrating that with AI will become a challenge due to this executive order. EDR, endpoint detection and response. Endpoint is basically anything with an IP address, but also includes thumb drives, external drives. Again, the requirement is continuous monitoring to identify patterns of that might be a threat. The use of artificial intelligence, by definition, involves the pointing the AI at data and information. So it becomes an endpoint issue that needs to be addressed according to this executive order. Threat detection, automatic responses to malicious activities. All of those things would have to be integrated into an AI that an organization, the federal government, would have to use. So all of these things present some challenges to the use of AI. Next slide, please. Executive Order 13960, safe and secure, trustworthy AI in government. When I read through this executive order, it became clear that there were some things that need to be balanced very carefully. One requirement is for promoting innovative and innovation in artificial intelligence while at the same time adhering to ethical, legal, and privacy standards. Well, when you point an AI at data, at information, you by definition then expose the artificial intelligence to private sensitive data. So balancing, making effort toward using AI with at the same time adhering to ethical legal standards becomes a challenge. Requiring transparency in AI algorithms needs to be balanced against ensuring safe and secure treatment of data and information. So how do you expose the inner decision calculus and architecture of an artificial intelligence system while at the same time ensuring that the information that is being pointed at is secure? That is almost a paradox that needs to be reconciled. So that's another aspect. Let's move on to the next one, executive order. The final one is 14110. There are other executive orders that are relevant. These are the three that struck me as most important. And in this presentation, I'm only going to be discussing the challenges and obstacles. We do not address here any of the solutions. We're hoping that those solutions will come through the careful orchestrations of the chief AI officer, which was required by this executive order throughout the federal government. So hopefully agencies will be onboarding a C-suite executive chief AI officer who will help solve some of the obstacles that I present here. But the problem with this new role of chief AI officer is we don't know much about that role. It's a new and complex job. The duties are to plan, measure, and address gaps in AI talent, to attract and hire AI talent, implement AI training programs. We don't have very well-structured models for that. We don't have competency models that represent that yet. We're working on them, at least at Census, but I can speak to other agencies. I work for U.S. Army. I work for U.S. Merit System Protection Board. Government is a bit behind the eight ball on making progress on that. We're working on it, but it's still a challenge. And of course, the biggest challenge, with recruiting AI talent is very stiff competition from the private sector. So getting people on board who understand how our AI works and how to get it to speak to our existing systems will be a challenge because of external competition. Private sector can afford to pay a lot more, and these people who have these kind of skills are very rare. So that in itself is a challenge. Next slide, please. Another thing I've run into is the requirement for FedRAMP certification. FedRAMP stands for Federal Risk and Authorization Management Program. It's a certification that a platform might receive in order to host and house sensitive federal government data. And getting that certification is very time consuming and requires a lot of effort. And most importantly, in order to host information that can be accessed by a lot of external AI like ChatGPT and Julius and other large language models, if they're not internally hosted, they need to be externally hosted. And if they're externally hosted, they need to be FedRAMP certified, which is a long process. And so whether or not we're able to use AI for conducting a lot of our business may well hinge on the hosting organizations outside of government even to get that certificate. I've reached out to several organizations, and it's all too new, and very few, if any, are trying to get that FedRAMP certificate that would allow federal government to then play in those sandboxes. We have to host our data somewhere in order to point the AIs at the data if it's not internal. So this becomes a challenge. Obtaining permission from all of our gatekeepers is probably going to depend on the hosting site where we will use our AI to have this certification. So that's another challenge. Next slide, please. Ethical challenges, bias and discrimination is a concern when using AI, especially in human resources management. There's a concern that biases that have historically been present in the past might be perpetuated by the use of artificial intelligence. A lot of what we do is personnel selection. So if we train an algorithm, for example, to select people based on their performance, the algorithm might well identify that education, as I have modeled here, education might be an excellent predictor of performance, but unless the algorithm knows that socioeconomic status might affect both of those independent and dependent variables, that bias would be perpetuated. There's a concern about that. Same thing for talent management and succession planning is another potential use for AI in human resources management and government. Whether or not someone goes to federal leadership training and their success at that training might well be a task set forth using an AI algorithm looking for predictive models. But again, there's that pesky problem of some kind of bias. I'm modeling here socioeconomic status, but it could be racial or sexual bias as well. The same thing that makes an individual get nominated to go to federal executive training, socioeconomic status might also affect their perception, their supervisor's perception of success, thereby embedding, it's cooked into the cake, if you will, a bias. So there's a concern about this. It's all over the literature in psychology. So this is an ethical challenge. Finally, performance assessment. AI can be used to monitor people's performance, but it's really good at monitoring metrics and hard criteria data, and not so good at capturing qualitative rather than quantitative achievement. And that could result in individuals not being given full credit for some of their non-tangible achievements and favoring those with more metric level achievements. That's a concern and a challenge. So next slide.
Right, and you have about 2 minutes left.
Privacy concerns. PII census, specifically more so than a lot of agency, requires that people trust the United States Census Bureau. And once we lose that trust, we can't get it back. So we have to be oh so careful with privacy and PII that we point any potential AI at. So that's a concern. Next slide, please. Transparency. We have a requirement that the AIs be transparent, that the decision calculus used to make decisions be obvious and be traceable. But a lot of AI algorithms are black box, they're opaque and difficult to see the actual decision calculus, and that's a problem if we require transparency. And if we can't capture the decision calculus, there might be thousands of lines of code. Holding systems accountable and tracing errors becomes very difficult. I show here a simple regression equation, y equals mx plus b, nice simple math, versus the extreme complexity of a lot of AI black box decision-making algorithms. So requiring transparency is a concern when you're dealing with complex AI. It's difficult. Next slide, please. Psychological obstacles, people's fear of job displacement, just like back in the last century, people who used carrier pigeons to transport information were concerned that the telegraph would do away with their jobs, probably a legitimate concern for them. But in modern times, routinized tasks are vulnerable to AI replacement. They just are. The more structured the task, the more people are vulnerable to AI replacement. Shifts in AI skills. AI requires, at least for things like large language models, prompt engineers, and having that skill set is something that people are going to need to acquire as they use AI. And of course, economic uncertainty makes the problem of fear of job replacement all the more concerning. Next slide. Fear of depersonalization. I created this image just by asking ChatGPT. I need an image showing AI depersonalizing the workplace. So it's very good at creating images that don't have to be ripped off from the internet. Here we see fear that the AI will transform the workplace into task-focused sweatshops, increase human isolation, produce loss of control and personal autonomy as the AI takes more and more control of systems and human beings. That's a concern. And it's just, there's a concern that AI will create a chilling effect on creativity in general. So these are all obstacles. Next slide, please. Fear of AI itself. 2001: A Space Odyssey, HAL, the T-1000 from the Terminator, Skynet. People have a lot of wild ideas about what AI is and what it isn't. Just general unfamiliarity with what AI is, what it can do, and how it works. There's certainly age and socioeconomic status covariates to fear of AI. I'm 60 years old. I'm not afraid, but I have a lot of colleagues who are. Socioeconomic status, those who don't have resources to use some of these systems might be more afraid of them. And human beings are just resistant to change. And there's some justifiable perceived complexity of AI that makes people shy away from it. It's too complex to understand and to work with. Next slide, please. Concerns over ownership of AI-generated content, new definitions of what plagiarism is. Do we copyright that which we produce from a large language model? What's a prompt engineer and what's the authorship that flows from that? These are all questions that need to be answered, and there's a blurring line between what human beings produce and what they're assisted in producing by AI. And that has to be negotiated more so before we move forward. What do you own when you produce content out of AI? Is that yours or is it someone else's? There's a prompt engineering institute that opines on that. So just something to consider. Next question, next slide, please. AI content detection measures. If you're going to try to detect plagiarism using these kind of systems, they don't work very well. A lot of false positive errors, and those false positive errors can adversely impact non-native speakers who tend to use AI to supplement their language skills. And if there are a lot of false positive errors, people who use that more so are more likely to be identified as plagiarists, even though it's ambiguous. Next slide, please. And finally, bureaucracy. If you're going to get permissions in the US federal government to use artificial intelligence, you're going to have to jump through a lot of hoops and be persistent and be okay with a lot of that administrivia. Tolerance and patience for administrative hurdles will be essential. You can't give up easily. Many forms and permissions will have to be sought in order to move forward with any permission to get artificial intelligence to be used in your organization. So that's it. Next slide. So, conclusion, AI adoption is constrained by a lot of legal issues, including executive orders. There are ethical concerns that persist. Certainly privacy concerns, especially if your agency is bread and butter is based on privacy. And transparency. AI tends to be opaque, and requiring transparency is something that needs to be balanced, that needs to be reconciled. And finally, humans have a lot of psychological issues with the emergence of AI in general, and we discussed some of them. So yeah, last slide. I'll invite questions at the end, which I believe we are at now. Thank you.
Yes, thank you so much. I apologize that we went over. Thank you so much to all of our speakers. We don't have time for questions, unfortunately, so maybe our speakers could put their emails in the chat so that if people do have questions, they can follow up with the speakers. I apologize for that, but they do need to start setting up for the next session. Thank you so much for joining us.
Welcome and thank you for standing by. All participants are currently in a listen-only mode until the moderator cues you to raise your hand for verbal questions. Though the chat function will be open where you can chat anytime and ask questions and comments in chat. This session is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn the call over to the main presenter, Karen Moyes. You may begin, Karen.
Thank you very much. Hello, everybody. Thank you for joining me today and welcome. I'm Karen Moyes from Westat, and we'll be talking about some best practices for accessible data visualization. My presentation will be about 30 minutes, so there'll be time for questions afterwards. However, I will stop it in periodic spots to ask if there are any questions about anything that's that I have just talked about. So, agenda. So first we're going to talk about considerations, things to consider when developing or designing accessible data viz. The relevant success criteria, excuse me, which is the Web Content Accessibility Guidelines, or WCAG. Some examples, the benefits of accessibility in your data viz, and then we'll have a question session, and then I have a resources slide at the end with some links of things that I'm going to talk about. So first of all, things to consider when you're doing data visualization. Consider the color contrast, your use of color. Let me take a step back. So data visualizations are by definition visual. So besides those who may have disabilities that are visual, your audience may also include people who have auditory, motor, or cognitive disabilities, among others. So how do you ensure that your audience understands your data, no matter what? Consider your color choices, both how you use color and the contrast. Keyboard accessibility is important because not everyone uses a mouse. Font sizes and readability are key for those who have low vision or may have dyslexia. And using plain language and intuitive clues will help those who may not be native language speakers or have cognitive disabilities. Make sure to keep your data viz simple, because after all, one of the reasons why you're presenting the data visually is to increase your understanding, their understanding. Be sure to use effective labels and think about providing an alternative method of presenting your data to allow your audience additional ways to understand. So one of the most important considerations is usability testing. It's easy to make assumptions about whether a color is good or if something is intuitive when you understand the data. But by using people who may have one or more disabilities to sample or test your visualizations early in the process, you will gain a better understanding of how to design and develop more inclusive and accessible data viz. It's particularly useful if you can target people who represent your audience. When you design and develop accessibility from the start, you will not only save time, but your budget. Imagine having to redo complex maps or charts multiple times because they aren't accessible, especially if you're close to publishing or rolling out the site, or you didn't test early enough in the process. By taking some extra time during your planning to consider how best to present your data in an accessible manner, not only will you reach the widest possible audience, including people with disabilities, but a few extra hours of planning may save days, if not weeks, of revisions and be much more cost effective for your budget. So let's talk about the relevant success criteria that you need to meet in order to ensure that your data viz meets Section 508 or other broader digital accessibility requirements. I'm going to concentrate primarily on WCAG 2.0, which the revised section 508 standards incorporate by reference, but there are also some 2.1 criteria that target that are important consideration if your data is going to be presented in multi-modes. Also, I want to mention that currently the U.S. Justice Department under the Biden administration is enforcing WCAG 2.1, so you may want to give that a shot. It makes anything you can do additionally will make your content much more understandable and reachable to the broadest audience. There are several of what I have highlighted on the screen in the little dotted box. There is the 4 success criteria to consider for 2.1, particularly if you're going to be doing something that is a dashboard or interactive or has dynamic data. These are the types of things that you want to consider, particularly if you're going to be presenting on mobile devices or, as I mentioned before, multi-modes. But I'm not going to talk about all of them or we would be here for days. So what I'm going to do is concentrate on the biggies, the ones that I consider the most important to get, again, the widest understanding for your data viz, particularly charts, tables, maps, those types of things. So the, excuse me, the criteria I want to focus on first is 1.1.1, which is non-text content. Then we'll jump to 1.3.3, sensory characteristics, use of color at 1.4.1, and contrast minimum 1.4.3. And then we're going to touch on 1.4.11, which is non-text contrast. So beginning with the non-text content, the criterion states that all non-text content be presented to the user. All non-text content, in other words, an image or a graphic, should have a text alternative that serves an equivalent purpose. So for data viz, that means that the data should also be available in a list or a table or some other text-based format. This is important particularly for infographics that tend to be a lot of images that have text with them. Visually, it may be simplified and understandable, but if you can't see it, or if you don't understand it, if there's a lot going on, then there should be another way to convey that information. Next is 1.3.3, sensory characteristics. So this criterion says that instructions providing for understanding content should not solely rely on sensory characteristics, which means shape, color, the size, visual location, sound, or orientation. So this one can be really tricky with data visualization because it is, of course, visual. It usually has a lot of color and may use shapes to identify items. This is where intuitive labels, how you use color, and color contrast come into play. So speaking of using color, SC 1.4.1 use of color is next. This criterion ensures that color is not the only visual means of conveying information, indicating an action, prompting a response, or distinguishing a visible element. This one seems to be the trickiest SC for data visualization, particularly when it comes to charts, maps, and diagrams. So I'll explain more when I go into the examples of why and how to maybe fix some of those things or what to consider. So contrast minimum, or success criteria 1.4.3, says that any visual representation of text and images of text should have a contrast ratio of at least 4.5 to 1. So there are some exceptions like large text and logos. So let's make the distinguish between large text. So large text usually means 18 points or 14-point bold in most fonts. So anything smaller than that, 16-point non-bold or 12-point bold would be considered regular text. Excuse me. So basically, this criterion states that means that the text should have enough contrast against the background to be seen by those who have low vision or who may be colorblind. There's a handy dandy tool that I like to use that helps determine if your text passes or not. So don't worry, you don't have to worry about the math. The tool will do it for you. I'm going to show a sample of it, and then I will, I have the link in my resources as well, so you can download it, it's free. And then finally, the one success criterion for the 2.1 is non-text contrast. So this one has to do with visual representation of graphical objects or user interface components that are right next to each other. So there's an adjacent color. So these should have a contrast ratio of at least 3.1 to each other. So this one's critical for charts and graphs. So let's jump right into the examples. So I'm going to show you a few examples of data visualization and how to ensure accessibility. Rather than thinking outside of the box, I like to consider there is no box. So to kind of paraphrase from the Matrix, where there was no spoon or is no spoon, there is no box. Don't box yourself in. Enjoy the creativity. It may take a little bit of extra time up front, but once you get into the swing of thing, I think it allows for much more engaging visualization of data. Before we get to the examples, I want to share my go-to tool that I just mentioned. So this is a free tool. It's available online. The website or the URL is shown there, and I'll show it again in the resources. But it's a color contrast analyzer. It's a drop. You use the dropper to sample colors. The image on the left shows the tool with everything basically collapsed. And while it's WCAG 2.1 results, if you pass them, then you're good with 2.0. The two that you really need to concentrate on are 1.4.3, contrast minimum, which is the top section, and the bottom one, non-text contrast. So on the right, I have the same tool with the paraphrased information showing. So it kind of explains what the contrast ratio should be for regular text. It explains what regular and large text mean. And then at the bottom, it explains again what the graphical elements with the contrast against adjacent colors, and that means right next to each other. So that's an important distinction, as I'll show you when we get to some maps. So map one. This is a sample. It is a representative sample. I don't want anybody to judge me for not highlighting certain states that I didn't say I wanted to visit. But I wanted to point out, so I have a US map, simple US map, has got some borders. It's got the state names on it. And then it's got some colors. There's a color key that says, it highlights, 4 areas, 4 states that I've lived in, several states I've visited, and a couple of states that I want to visit. And they're all in different colors. So to make sure that it passes color contrast and use of color, I'm going to use the tool that I just showed you. So I already know from experience that the white text that's showing on that bright gold is probably not going to pass, but I'll check just in case. So nope, it failed. So, and it's very easy to see whether you failed because it's got a big X and it says it fails. So what do? So it fails for everything. So it really fails. So it's because the borders are white. So not just the text in this case, but the borders are white. So it also fails, particularly where the states, there are states of the same color, the same yellow color against each other with the white. It's going to look like, if you can't distinguish those two colors, it's just going to look like one big blob. So I need to fix that white on yellow. The easiest thing to do would be to take the white text on those particular colors and make it darker. But what about Florida? Because Florida is on a white background, there's no border. What if I make something darker and it changes the border? It's surrounded by white text, so it's still going to fail the contrast. This, so that solution probably won't work. Making the borders darker might work, but then we have the darker colors. So then we've got the adjacent colors, and then we come into a huge conundrum. So as you can see, there are a few different issues here that needs consideration. All of this takes time and creative thinking. So this is why it's critical that you do this early on in your process. So here's one way to solve that solution. So this is a quick and easy way. I just darkened the background behind it. And I see your color, and I will answer that, Claudia, in a second. I see your question. So what do you do if you've got your colors? I'm sorry. So what I did here was a quick and dirty, dark background. And then as you can see, I also changed the text in the white. So everything here passes color contrast as well as use of color, because I can see it no matter what. So the bottom line is to check everything and consider your options. So another way to do this would be to provide a table or a list of the states, so it's an alternative version, so I can still get the same information in an equivalent way without having to rely on color. It doesn't have to be on the same screen or page, but a link should be available right there along with this data visualization, so that people know it's there and that they can make the choice to go get the same information in another way that doesn't rely on color. So I'm going to stop here, and Claudia says, what do you do when you need to have a consistent label color, but some color fail? So without seeing something like that, and maybe that is something we can talk about offline, I will provide my email to address. It really just depends on how you've laid that out. So if you need to have a consistent label color, but some colors fail, if it's the label colors that fail, then maybe you do something like this and you put a dark background in, or maybe you label it differently or in a different area. It's really hard to visualize what you have asked without some kind of representation. So if that didn't, yes, or do the table, exactly. So you could also do the table, or do it as a table or a list. That would solve your problem. It would give you an equivalent information. So, okay, so that's cool for color contrast. Well, what about if I'm colorblind? Does that work for that? So here's that same map. The first map, not the second one in the background. So what I did was I dropped this image into a color blindness simulator. And as you can see, I chose, in this case, this just happens to be for somebody who might have a red, they don't see red very well. As you can see, the colors are very different here. But I can still distinguish them, except for the fact that my text is still white here. I would change the white text in the lighter colors, but for the most part, I can still distinguish those colors. So what I chose, the colors I chose, still work okay with the simulator. You can drop this in. The source here is for the Coblis color blindness simulator. It's one of many that are out there. It's free, and you can drop your own images in. It's a good quick check. But there are many out there. You know, a quick search, internet search will bring up several, and for the most part, you get the same results. But I recommend that you take a look at this. After you start doing this a few times, you'll have a better understanding and idea of what colors might work well with others. I know this can be tricky if you have specific branding that you have to use, but in some cases you may have to, again, forget about the box, blow up the box, and come up with some different creative ideas. So let's talk about charts. Oh, before we talk about charts, are there any other quick questions on, the map or things? If not, then I'm going to move on to charts. No hands, no questions. All right. So let's talk about charts. So here's a simple bar chart. I've already checked the colors using my handy dandy tool, and all of them pass the contrast against the white background. So another thing that's really good to consider when you're doing something like this is white space in between your objects. So as you can see, each category and series, there's white space in between the bars. If I had them all shoved right next to one another, then I would have to worry about that non-text contrast, the one at the bottom for graphical items, and then I would have a whole other issue. I would pretty much sure that all of those would fail. I would have to sample each color against their adjacents, and for the most part, I can pretty much ensure that several of them would fail. So that's why white space is always really good, because that way you don't have to turn on borders or figure out, what to do. It's a quick and easy way to do it. Excuse me. But what about relying on color to identify the series? So that's where this is. You shouldn't assume that people will automatically know or understand that the order of your key or your series, where I have 1, 2, 3, 4, 5 series, in the different colors at the bottom there, follow the same order as the bars. For the most part, a lot of people do that, but in some cases, particularly if you have a lot of series to put on there, it's not always possible. You may not have the space. You might have to, group them separately or differently. So what do you do in that case? Because you can't, again, if I'm colorblind or I have a problem differentiating the colors, what do I do? So there are other things you can do. The simplest thing to do is to add another level to your series or to your axis and identify, again, this is a very simplistic way to do it, but it helps identify it. So that way I could mix up the color key, and put them in any order I want. But because I've identified each bar in each category, I don't have to worry about the color to understand which bar in category A goes with which series. So again, it may not be possible if you have a lot of items, but the other thing to consider is if you have a lot of items, maybe a bar chart isn't the best way to present that. Maybe you want to do a combination, throw some lines up there. And if you're going to do lines, keep in mind that changing the line color is not going to necessarily suffice. So you probably want to put different symbols for your data points. There are so many different ways to do this. It's very hard to pin down just a few, but again, if you throw away the box, don't think about it, use some creativity, do some different things, then your data viz will be more engaging, and it will be much more accessible. So let's talk about heat maps. Heat maps are always very timely and important, put a lot of data, very colorful. So I have some examples here from the gisplanning.com products page. This is not a free product, but it is a nice way to handle this for color blindness. So the heat map on the left is normal view, and it shows the ranges of the men's apparel and the pricing in colors. Well, but if you're colorblind, you're going to see something similar to what you see on the right. Everything's going to look the same. Some of the gradients are going to be really hard to distinguish from each other. And 3 ranges in particular will be very hard to differentiate. So one thing about this tool, this section, but you can add it to anything, is, there's lots of ways to do this. This is one of them. Here's what they did. They have patterns set. And I have simulated the same map that we just looked at, simulated for 2 different types of color blindness using patterns. Now, I'm not a big fan of patterns, but it does help the data be more understandable if you can't see the colors. Another thing to consider that I usually use, if you've got like a range, like a temperature map where you've got your little ranges very close together, use a symbol, use a different symbol for each range, or use a number, 1, 2, 3, 4, 5, especially if there's a progression from like cold to hot. That's an easy way to distinguish it. And then you put your key at the bottom. You can use the color, but you use the numbers as well. And then you're not relying on color alone to understand the information. So that's pretty much it for my examples because there's so many you can do. However, I want to talk a little bit about the benefits. So by making your data visualization accessible, not only do people with disabilities benefit, but everybody benefits. For example, again, multi-modes, people using smart or mobile devices might be viewing something on a smaller screen. Older audiences with changing abilities, those or they might be not tech savvy and don't understand that there might be another way that they could take a look at it. People with temporary disabilities, like maybe they have a broken arm, lost their glasses, they can't use a mouse, they can't see something, they have to zoom it in, do something like that. It could be somebody who has low vision or is colorblind. It could be hard of hearing if you've got some interactivity, some sound types of things. It could be a situational disability, such as maybe somebody is viewing this in an airport that's very noisy. They're in an overly bright or an overly dark environment. By not relying on color alone and a higher contrast, they'll still be able to get the information. Accessible data viz also helps with slow connections or limited bandwidths because you're not relying too much on what's happening. And another one that people I think sometimes forget is people who have aren't non-native language speakers. So something that is intuitive, maybe we're using jargon or something that doesn't that makes sense to somebody else, to you, but somebody coming from another country or doesn't speak your language, whatever language it's in, natively, making things, considering all those other accessible criteria will help everybody understand that. So, as I mentioned, free resources. The first one is a quick reference from the WCAG site. I highly recommend going out there. It's a really nice, simple way to filter. You can filter down to your specific criteria that you need for whatever you're developing. You can, once you choose the filter options, for example, visual design is an option. It will bring up all the criteria that relate. You can then choose which version of WCAG you want to meet, 2.0, 2.1, 2.2, and then the priority levels. At a minimum, you want to meet A and AA. AAA is great. The more criteria you meet, the better your accessibility is and the wider audience that you will reach. So the next link is a color blindness simulator that I showed earlier. And this is really cool. It's really good, and you can change everything. It's just you can choose all your options. You can upload your own images, and it's a really quick and easy way to get information. And then last but certainly not least, the color contrast analyzer. It's one thing I like about that is it's cross-platform. So it downloads it installs on your system. It's a local download, it's free, but it's cross-platform. So for those of us who started in design and still use Macs, it's one of the few tools that works cross-platform. Questions? Raise your hand or nothing on the chat? Nothing? All right, well, thank you very much. Feel free to reach out to me. My email is Karen, Karen, Moyes, Moyes, at Westat, WESTAT.com. Oh, okay, Claudia, I'm waiting. Claudia is typing. You could unmute yourself, I think, Claudia, if you want to ask. You're quite welcome. Thank you, Allison. Claudia, are you still typing? That I don't know. I do not know if those tools can be used on your census computers. That would be a question for your admins, but I will say that the trusted, if they allow the trusted tester recommended tools, the contrast analyzer that I showed is one of those from the DHS trusted tester recommended tools. So hopefully that's a good indication that it was. Yes, so you are welcome. Any other questions?
Hey, Karen.
Yes.
This is Carl Ramirez. A quick question. To what extent do you think the graphics design tools, and other apps that we actually use to create things are going to be building in the WCAG standards and other things? I mean, I realize you're advocating for the testing using these tools, but not to name specific products, but do you think increasingly, hey, we'll be able to design usable and readable graphics through the apps we use to create them?
That's a great question, and I've wondered that myself. I think right now, depending on what you use, some of the tools, some of the Adobe tools for design have accessibility checkers built into them, so you might want to check that. And they may point out color contrast issues. For the most part, I have not seen any from a design standpoint. I tend to use tools like those checkers online or web types of things. So I have not seen anything that's built in, but I will tell you that I think this may be one of those opportunities for AI to help on some of those things. I think that is something that may be tested and maybe it's coming. I haven't seen anything yet. Does that help?
Yeah, thank you. That's just trying to get the context of what we're up against in the future. Thank you.
Yeah, I think really a starting point, Carl, would be to go out to that quick guide for the WCAG. And the nice thing about it is it gives you failures, so like things that won't pass or whatever. And I think they're going to be adding to that. So it's possible that they may have some other suggestions in there, but I think AI, like I said, has a role in this. And but for right now, things like this is still a bit manual, although there are some applications that like Adobe Acrobat has an accessibility checker that does tell you if there's color contrast in your files. I believe Word may also do that. Of course, that's not a design tool, but PowerPoint does it. But for the pure design tools, I think InDesign also does it. But for pure design, it just all depends on what you're using. Okay, well, if there are no other questions, I'm going to thank everybody very much and let you go a little bit early.
1. Welcome and thank you for standing by. All participants are in a listen-only mode until the moderator calls for verbal questions towards the end of the speakers. Today's session is being recorded and may be posted publicly. If you have any objections, you may disconnect at this time. I would now like to turn the session over to your moderator, Catherine. Catherine, you may begin.
Thank you, Anthony. Hello, everybody, and thanks for coming at this late hour. You're in the Track A session, Balancing Tradition with Innovation During Unprecedented Times, Lessons from the 2022 Survey of Consumer Finances. We have 5 speakers this afternoon, 4 presentations, and we're going to start with Heather Sawyer, who's a Senior Research Director at NORC. As an applied economic and environmental anthropologist, she's conducted work on a variety of topics, including household finances, the informal economy, race and ethnicity, barriers to entrepreneurship, climate change, and natural resource economics. Heather, it's all yours.
Okay, thanks so much, Kathy, and welcome everyone. Thank you for joining our panel today. Since all the presentations in this panel are based on the Survey of Consumer Finances, I wanted to first take a few minutes to give you some information about the study before we dive into the individual presentations. The Board of Governors of the Federal Reserve System funds the Survey of Consumer Finances, which has been conducted every 3 years since 1983. NORC has collected these data since 1992. The study serves a unique role in providing information about household finances by collecting data about the financial institutions the respondent uses, their assets, liabilities, employment, retirement benefits, and demographics. We use a dual sample frame, which includes both an area probability sample and a list, which includes an oversample of people with high wealth. And these data inform policy on a broad range of topics that impact the lives of all Americans. Okay, so with that, I will give the first presentation in this panel, which is titled Examining the Use of Computer Audio Recorded Interviewing to Enhance Cultural Responsiveness on the Survey of Consumer Finances. Okay, so here's an overview of my presentation. I'm going to start with an introduction and look at sort of the research problem, look at sort of some aspects of data quality, look at CARI and its uses, and then I'm going to present a case study, which is the SCF, and then I'll end with a discussion. So the Survey of Consumer Finances has a really robust data quality program, which has been developed over several decades. This includes more traditional, trusted approaches to data quality, but there are also some SCF-specific checks performed, such as reviews of every single completed interview by Federal Reserve Board economists. And each round, we look for ways to apply innovative approaches to data quality. So, for example, over the last 2 rounds of the survey, we've started using GPS data to inform data quality monitoring, and we've also created a model to predict likely falsified cases. So with that context in mind, my presentation today examines the potential usefulness of CARI, which are audio recordings taken during an interviewer-administered survey that capture interactions between interviewers and respondents. And I'm going to look at this as a way to further enhance data quality on the SCF. So under this broad umbrella of data quality, I used the lens of culturally responsive research to examine how CARI could be leveraged for additional insights. And to do this, I'm going to use 3 touch points from the SCF. But the goal is that the examples I discussed today could be instructive for other interviewer-administered surveys as well. Okay, so posed in the form of a research problem, field interviewers are uniquely positioned to observe if surveys are culturally responsive to a range of respondents, yet there are few opportunities on large-scale projects to really capture these insights. So a little bit of background. Much of the work done regarding cultural responsiveness in surveys happens prior to data collection and before interviewer involvement. And as a result, interviewers are not often included in these discussions. However, I argue since interviewers play a primary role in implementing culturally responsive instruments and protocols, their direct interactions with respondents could provide valuable insights about if data collection plans are connecting with respondents as intended. So the question is, could Carrie bridge this gap? And I think this is an especially important topic now against the backdrop of major stressors such as lingering impacts of the COVID pandemic and increasing natural disasters, which have significant impacts on household social and financial arrangements. Okay, so now turning to data quality and culturally responsive research. Okay, so what is culturally responsive research? This is a really broad topic, but can generally be thought of as addressing 4 main issues. So the first, who is represented in the research? Next, who benefits from the research? How legitimate is the research to diverse perspectives? And then how is the research initiated? So the last topic of how is the research initiated may seem to be the most directly applicable to the work of field interviewers as they interact with respondents directly in this way. But in really thinking about this issue, I argue they can play an important role in monitoring the first 3 issues as well, potentially through the use of Carrie. Survey research utilizes a variety of tools to promote cultural responsiveness and promote high quality data before main data collection begins. So this includes things like semi-structured interviewing and focus groups, cognitive testing, pilot testing, and careful translations. And then once data collection begins, there are numerous ways to monitor data quality on surveys. This is typically done through the use of paradata, which is data about the processes by which the data were collected. And this may include things like total interview length, duration of specific items, straight lining or unusual response patterns, percentage of questions answered, GPS or location of interview information. We may look at call records or level of outreach effort. And then there's also interview validation. So based on that, we know that there are numerous ways to refine cultural responsiveness before data collection begins. And then we know there are numerous ways to monitor data quality during data collection. But these data quality efforts don't usually include cultural responsiveness. So the question I'm sort of left exploring here is, can we carry assessments of cultural responsiveness through the full survey life cycle, and can Carrie play a role in this? Okay, so here's some additional background on Carrie. So what is Carrie? Okay, Carrie stands for Computer Audio Recorded Interviewing. And like I mentioned at the start, these are audio recordings taken really behind the scenes in an unobtrusive way during an interviewer-administered survey. So Carrie offers a way to monitor interviewer interactions to assess aspects of data quality in survey research. And so the traditional use of Carrie is to enable an analysis of interviewer performance through behavior coding. And Carrie is really growing in popularity as a tool to validate interviews. But researchers are also using Carrie for expanded data quality efforts. So this includes things like identifying problematic interviewer behavior, reducing measurement error, reducing respondent burden, and a potential use for Carrie that I'm examining here is the role it could play in culturally responsive research. So that's sort of how it fits in sort of to the bigger picture of Carrie. Okay, so next I want to move into my case study using the Survey of Consumer Finances to sort of examine this issue. So we used Carrie for the first time in the 2022 SCF. Our analysis focused on validation of interviews and a few other data quality topics. In total, the research team reviewed approximately 4,000 cases, which was quite a bit. And with those cases, we performed behavior coding to identify data quality issues. So you can see the coding matrix used by the research team here in the table. So you can see it covered things like, as the research team was going through and listening to these recordings, do you hear another person besides the interviewer? Is there audio on each question? And then a series of other checks here. So does the interviewer use proper cadence when reading? Do they read the entire question text? Do they read all of the response options? Do they probe when applicable? And this is really SCF specific, but does the interviewer repeat back dollar figures to the respondent to really confirm figures are right? So what I'm going to do then is look at 3 survey touch points to examine if Carrie could be helpful in assessing cultural responsiveness. And so these include, first, the household roster and respondent selection. Next, some newly added COVID questions that we added for the 2022 round. And then last, our Spanish translation of the questionnaire. So the first area of the survey that could be monitored and evaluated for cultural responsiveness is our household roster and respondent selection. Household surveys like the SCF can present challenges to both interviewers and research teams who design and implement protocols to identify the proper respondent and roster the household. Challenges stem from social complexities that don't always translate neatly to survey instruments, and interviewers really have to navigate these complexities then. So this is an image from our interviewer training, which shows the screener SCF interviewers use to determine the proper respondent with a household. So it takes into account household complexities, such as what to do if there's no head of household, how to determine the respondent when several adult roommates live together, and what to do when the respondent rents or leases a house rather than owning it. And then once the proper respondent is identified, the interviewer takes the respondent through a series of questions to map the entire household, including people's social and financial relationships, which presents a lot of complexity. So the household roster is designed to capture this complexity within the household, things like same-sex couples, non-relatives living in the household, and separate finances within one household. And we know that other household complexities may arise over the course of data collection that aren't built into our instruments. So we've made a concerted effort to sensitize field interviewers to a range of household diversity they may encounter through a series of culturally responsive research training modules. So in addition to flexible instruments and targeted training, using Carrie during household rostering could provide new insights about complex household arrangements in the US. For example, this could be especially useful in understanding if shifts in household relationships that we've observed because of COVID are permanent or temporary. In the 2022 round of data collection, we saw interviewer difficulty rostering some households when things happened like adult children moving in with their parents due to a financial hardship, or elderly individuals moving in with their adult children because of prolonged illness. So with Carrie, we could better assess our approach to household rostering, evaluate response options, and identify if there's a need for additional trainings to be more responsive to recent household shifts. Okay, so the second survey touch point could be examining our newly added COVID questions. So these were added in 2022 to capture the impacts of the pandemic on a range of topics such as financial hardships and how they were dealt with. And two questions asked about topics that may especially be impacted by cultural understandings of disease and its spread. So the first question, have you or your partner ever been diagnosed with COVID-19? And then the second, did someone who was living with you during the pandemic die from COVID-19 or an illness that you suspect was COVID-19? So knowing that not all groups or cultures conceptualize disease spread in the same way, it could have been useful to gather additional information on how respondents thought through these questions. Things like the word diagnosed could be examined through a cross-cultural lens, as well as how people think about the relationship between a COVID diagnosis and a subsequent death of a loved one. So examinations like this could help ensure the survey is valid to diverse perspectives and inclusive of varied ways of understanding the world. Okay, and then the third survey touch point is with our Spanish translation of the questionnaire. So the SCF utilizes a committee approach to translations, and what this means is that a committee of native Spanish speakers are engaged to independently review questionnaire translations. Then they come together as a group to discuss the best translation to appeal to a wide range of Spanish speakers who are known to live in the US. So using Carrie to capture interviewer interactions with Spanish-speaking respondents could help assess the cultural responsiveness of specific survey items in a way that sort of evolves with these populations. For example, diverse Spanish speakers may have unique words for certain financial services, could use financial tools unnoticed by the mainstream banking community, or conceptualize household financial arrangements, such as what constitutes a dependent in different ways. So an analysis not only of the translations, but the inclusivity of financial concepts and tools may help ensure the survey is serving our Spanish-speaking respondents so that the data are representative and inclusive. Okay, so that brings us to the discussion. Okay, so why use Carrie to monitor cultural responsiveness on interviewer administered surveys? So first, there may be a gap in time between things like cognitive testing and main data collection, especially on longitudinal surveys. So I think there's a tendency to test new survey questions on these longitudinal surveys, but to re-administer existing survey questions that have proved culturally responsive at one time. So using Carrie would give researchers insights outside of formal testing. Second, when administered as part of ongoing data collection, issues may be identified earlier. Third, continuous monitoring allows researchers to assess survey questions in light of rapid socioeconomic changes. So we could think of the COVID pandemic or an economic recession. Fourth, we can monitor broader social trends that really sort of build over time and better identify when they impact data collection. So here we could think of redefined gender roles or the declining prevalence of the nuclear family in the US. And last, Carrie can provide valuable sociocultural context to reduce measurement errors. We could think of the COVID questions that I discussed. So for all of these reasons, I argue the thoughtful use of Carrie in survey research offers an opportunity to strengthen the inclusivity and representativeness of diverse participants. Okay. Thank you.
Thanks, Heather. Oops. Oh. All right. Thanks, Heather. Next, we're going to hear from Shannon and Callie. Shannon is a senior research director at NORC and is responsible for the overall management of projects, including staffing, data collection and delivery, and budgeting. Her experience includes directing data collection efforts with hard-to-reach populations, including those with multiple sample types, requiring tailored strategies, as well as maximizing multi-mode strategies to meet project goals. With Shannon is Callie Baer, a research associate at NORC. She's worked on a variety of projects, including the National Longitudinal Surveys, the Medicare Current Beneficiaries Survey, and the Survey of Consumer Finance. She's played a key role in materials development and mailings, as well as designing training for field staff. I don't know which of you is going first, but take it away.
All right, I'll go ahead and share my screen here real quick. All right, Shannon, whenever you're ready.
Thanks. Thank you, Callie. Thank you, Kathy. I am going to be discussing field interviewer training, the SCF, some experiences we had in 2022, and then some thoughts we have about, what future trainings could look like. I am going to set the stage a little bit and provide some background, and then Callie is going to walk you through our ideas for what a new hybrid model could look like. All right, so some important background so you can really understand how our trainings are developed and what our approach is and why they're that way. The FRB really, really cares about training. I've worked with a range of clients with varying levels of interest in training in my 17 years at NORC, and the FRB is of magnitude different than any of them. They are very involved. They want it to be comprehensive. They're willing to invest in it, and they take part in the training. This is because high quality data is imperative for them, and they believe that training is the mode to high quality data. They have a saying that says, stay out of the emergency room, which means that the data collected by the interviewers should be of such quality that they have to do minimal editing and imputing and fixing of the data. So interviewer training is at the core of the SCF. Two other things I want to note that are very closely related and important to our new proposed training model is that on the spot first attempt completes are pretty rare on the SCF. To set expectations for field interviewers, we used to tell them that maybe 10% of doors they knocked on would complete an interview during that first attempt. That number has been decreasing for a couple of reasons. One, we introduced a contact form recently that asked people to reach out to us and give us their information and schedule an interview with us. So the most eager beavers now reach out to us, so there's fewer of them available for interviewers who are knocking on their door for the first time. And as I'm sure everyone here is aware, respondents are just increasingly hard to reach. So the odds of catching them and getting them to do an interview the first time you meet them are reduced. Closely related to this is that the SCF questionnaire requires a lot of commitment and trust on the part of the respondent. The median questionnaire time for 2022 was actually 120 minutes. So that's 2 full hours. And it is not an easy 2 hours. It is a cognitive challenging time where people are asked to review their financial records, look at their bank statements, think about how they think about money, how they spend money, how they save money. So it's not an easy ask for them. Respondents are also very concerned when we reach out to them that we are trying to steal their identity and steal their financial information. So we train our interviewers to not push too hard for interviews the first time they meet people. We want them to establish legitimacy, to provide information, to tell respondents to check us out, to encourage respondents to ask us questions and to answer those questions, because the thought is, and the belief is that the more they trust us and the more they're committed to this interview, the higher quality data we can get. But that really means that very few interviewers complete interviews the first time they knock on someone's door. Not to state the obvious, but COVID changed things, changed everything really. For the SCF 2022 specifically, we had significant challenges hiring and retaining interviewers. Because of this, we had to make the most out of the team we had. And so we focused our resources to create these specialist teams. And this turned out to have the added benefit of really energizing our team. Interviewers loved the opportunity to get to pick a specialty and to really shine with that. And we found that it increased retention. People were really committed to the project, and the people that were with us really stayed with us. So this is something that we plan to use on other projects and to carry through for any future SCFs we might have the benefit of doing. The other thing about COVID is that we had to, for the first time, do a fully remote training. We had never done a fully remote training before. Our trainings had always been in person. But, you know, we were thrown into the fire. We had to figure it out. And since then, technologies have only improved, and there is now near universal acceptance of things like Zoom or Teams or using learning management systems in different ways. So these are things that we are going to carry with us as we think about what an ideal training could look like. So before 2022, we were all in person. Everyone would fly to Chicago. We'd sequester ourselves in a hotel for 4 days and live and breathe the SCF from the time we woke up till the time we went to sleep. In 2022, the exact opposite happened. Everyone was at their own homes, sitting in front of their computers, doing something very similar to what we're doing now, listening to presentations, and then having some chat and interactivity, but really people did not have the same experience. So in-person training and remote training each have their benefits. The best things that we could take from in-person training was the ability to help interviewers with their technology hands-on. If they can't figure out how to use their tablet, if they can't figure out how to use their laptop, if they don't know how to navigate the case management system, we can just walk over and help them. It's a simple fix. The role playing for gaining cooperation, really being with another person in person, is critically important, and you can only do that in person. There was a sense of team and team building that we saw at in-person training, that although we were able to create that energy later in the field period, in 2022, we didn't quite get there with training. And because of this, and because people had committed to getting on a plane and coming to Chicago and leaving their families and being at a training for multiple days, we saw that people had a higher level of commitment to the project. There were some benefits to remote training, though. You have so much more flexibility. You have the opportunity to spread things out a little bit. You don't have to condense it into 3 or 4 days, because you aren't paying for hotel space and for people to stay there and eat there and do all those things. So you can give people a little bit of breathing room. It also allows for a level of tailored learning that we really enjoyed. We could easily send people out into a breakout room if they needed something. We were able to create really quickly targeted LMS courses for people. And of course, there is the cost savings, which can't be denied, but it's not the only concern. When we've really looked back and reflected on our experiences previously and then our experience in 2022, we realized that though there were different modes, that some of the same big problems persisted. No matter what the mode was, fully in person or fully remote, it was just information overload, because we were training people on project protocols, on gaining cooperation, on using the instruments, on how to do administrative tasks, on how to use all the technologies. So while they had a great breadth of knowledge, we weren't really able to get very deep into anything. And we do have a continuous training portion on the SCF, but it's just not quite the same as the initial training. What happened with both modes is that interviewers go out into the field and their gaining cooperation skills still leave a lot to be desired, because they haven't had a ton of focus on just that. It was just one part of the bigger training. And honestly, a lot of time of the training is focused on the SCF questionnaire instrument, because the thought was that we have to make sure that the interviewers fully understand that instrument 100% before going out into the field, because that's how you collect high quality data. What we didn't consider or that we didn't really have the possibility of doing because we hadn't yet had the experience of remote learning, is training people in to do the gaining cooperation parts in person, and then to do the questionnaire parts remotely. So as we move forward, Kelly, if you go to the next slide, we are thinking that moving forward, that we can still focus on data quality, have team building by creating a training that is staged and really fit for purpose. And in setting up a training where the things that are best done in person can be done in person, and the things that are best or can be done with high quality can be done remotely, are done via that mode, then we can build a team of interviewers that is prepared and confident and would sort of be the best of both worlds. So Callie is going to walk you through a little bit of what we think that training could look like.
Yeah, thanks, Shannon. All right, so Shannon kind of went over some really important background information, but one more piece is that when we do our training, we have 3 groups that we have to think about tailoring our training to. Those groups include our new to NORC interviewers, our new to SCF interviewers, so maybe someone who's worked on another NORC project, but never on SCF, and then our SCF experienced interviewers. Each of these groups brings its own sets of needs and also challenges. We want to be careful about how we're tailoring our training to each of these. This is a general overview of what our proposed 4-phase model would look like for training in the future. So on this, you can see each phase, you can see the name of each phase, which groups those trainings are for, and then also the delivery method of either remote or in person. So I'll give you a second just to take that in. All right, so our first phase is our refresher training. This phase is specifically for our project experience field interviewers. We believe this phase is best suited for remote training because of the depth of experience and knowledge our field staff in this group already has. As the title implies, it is a refresher training. It will include any new tech and tools, new updates to the project, and it will cover our topical specialist areas that Shannon covered earlier. Even our project experience field interviewers will go through certification to ensure data quality and confident, well-equipped field staff. This is our first phase for a few reasons. It ensures that we have staff ready to hit the ground running when data collection starts, and it also means that we have experienced staff working in the field and able to assist and mentor new staff if they have questions or need any extra assistance. Our second phase of training would be the initial training, and this would be for our new to NORC and new to project interviewers. We divided up what content works best remotely versus what content really needs to be in person. The remote half will come first, followed by the in-person half of training. Our content covered remotely, as you can see, is our intro to the project in the role of field interviewer, an overview of data quality, of our sample design, and then also how to screen households. We believe these topics are best suited for remote work because of the detailed nature of this information. Field staff can take their time, go back if needed, and can do each of these sections at a time when it best suits them. Our content covered in person would be role-playing scenarios, like Shannon mentioned earlier, our technology and tools, data security, doing mock interviews, and then also our certification. We believe these topics are best suited for in-person work because of the teamwork they require, the personal skills that we can observe better when we're all together, and it is bringing all their work together for us to see at once before they certify. Our third phase is skill development. As Shannon said, we're really in the past had been able to give that breadth of information, but not so much that depth. So this phase 3 is really about getting that depth of knowledge. So the content covered in this phase would be our deeper dive into our questionnaire, into refusal conversions, again, our optional topical specialists, and then there would be a certification for this as well. This is for our new to NORC and new to project interviewers, just to give them, again, that depth of knowledge. And we believe that this phase is best suited for remote work because they will already have been in person in the field having interactions with potential respondents, so they can build on what they already know in a remote environment. And then our fourth phase would be our continuous learning. While the majority of the heavy lifting for training is at the beginning of a project, we always need to be in touch with our field staff for any project updates, any data quality notes, any peer-to-peer learning we can facilitate, amongst other things. By diversifying the modes and methods of continuous learning for all interviewers, we can ensure an engaged, confident, and well-equipped field staff, not only at the beginning of the field period, but throughout the project. So in this phase, we have all of our interviewers, this would all be remote, and some different methods would include weekly project memos, special topic group sessions, regional calls for our field staff, and then one-on-one calls for our field staff as well. And that wraps up our 4-phase hybrid model that we hope to implement in the future.
Thanks, Shannon and Callie. That's great. All right, our next speaker is Micah Schlobem, who is a vice president at NORC. Schlobem has directed teams implementing large-scale data collection and support operations on a number of projects, including the Survey of Consumer Finances, the Medicare Current Beneficiary Survey, the COVID-19 Resource Coordination Hub, and the National Survey of Early Care and Education to achieve results through implementation of flexible, process-driven operations. Micah, it's all yours.
Thanks, Kathy. All right, everyone. I'm going to try and shorten this up slightly. We're running close. I don't want to be between folks and dinner plans this evening or this afternoon. But I do want to share some of the findings that we had from the 2022 SCF that I think can be influential in how we reconceptualize field operations on a number of our large surveys of national importance. And I want to jump right in, talk a little bit about some of the challenges that were presented with at the beginning of 2022 fielding in April that year. There were a number of quickly emerging or continuing challenges that we had to pivot to address. The first being the widespread transmission that winter of the Delta variant, which really put into question our ability to be on the ground in the field. We continued to struggle with field interviewer labor shortages. And despite all of the mechanics and effort that went into our training program that Shannon and Callie just shared, it was an unknown quantity. It's the first time we were using a fully remote training program on the SCF. And certainly that linked to some of the risks and thinking about what that meant for our field data collection. We actually implemented a number of different strategies quickly to help us reconceptualize data collection. We looked at expanding methods for initial outreach out of necessity. primarily using phone in ways that we had never seen in initial contacts on the SCF. We looked for new strategies for engaging folks through our initial mailings, and one being the contact form, which I'll discuss here, but also some of the importance around pre-field locating, helping us really identify locations where our respondents might be. We had an emergence of additional specialized interviewer roles that played an important part of steering our data collection activities in the field. And we also had an increased need for better observations or enhanced observations of the type of outreach and what we were learning in the field as we moved through the data collection period. So what I'm going to focus on today, I'm going to talk about the contact form. I'm going to lightly touch some of the slides I have in here about what we found about pre-field locating, and then I want to return to some of our contacting efforts that really involve some of the higher reliance upon phone, at least initially, and talk through some of what we found. But for the contact form, one of the approaches we decided to implement the spring of that year, late winter, spring, was to develop this pre-field tool that would collect information from willing respondents upon receipt of the letter. The advance letter on SCF has traditionally been an announcement of the survey and an interviewer will be coming. But in this case, we wanted to not have willing participants wait. We wanted them to reach out to us. So this web-based form collects phone numbers, email addresses, and a preferred time to call. This example over here is kind of a cutout of what was included in both of the letters that were sent as part of the advance mail packet. There was also a little card that was included with instructions that had a unique PIN associated with each household that could be accessed through the QR code, the embedded QR code, or the URL. We offered a $10 incentive for submission, plus the note down here in orange. It's smaller, but that the survey itself had a $75 incentive. We also trained up a specialized interviewer team, a phone team of SCF experienced staff that were responsible for facilitating the contact information that came in, following up, setting appointments, and conducting interviews. So what did we find? There we go. Of the contact form activity, there were about just over 640 contact form entries submitted, roughly 8% of the households mailed. And over here on the right, you can see the number of contact forms completed across weeks out from the initial mailing. And here are the two mailings here. You can see the spike after the mailings were sent. Field data collection outreach started roughly 2 weeks after the first mailing arrived at households. Of those 642 contact forms, you can see in the far left here, roughly 82% were submitted in the first 3 weeks after the initial mailing. So pretty much right before interviewers could really begin to make initial outreach with their caseloads. In that first 3 to 4 week period, there were just over 300 contact form submissions recorded, and that completed interviews. And of those 304, that was roughly 3 out of every 4 complete that we had recorded during the first 4 weeks. So it was really an important tool in expediting, jump-starting our data collection. Of the contract form submissions overall, we ended up completing 550 interviews with those individuals, or roughly an 85% completion rate. So just kind of the takeaway here, thinking about some other opportunities in large data collection efforts. As we know, other multi-mode studies, even some of our mail push to web focused efforts, include opportunities to engage with participants and use mailings as an avenue, a strategy to engage with our participants. This is a way to look at expediting that initial contact rather than passive engagement, really encouraging and incentivizing folks to reach out. It's also important to note this was just one tool of many that we had in the portfolio. We did bundle this with a pre-filled cash incentive enclosure experiment that we ran, that my colleagues and the members of the board have done some fabulous analysis on. And then also thinking about how we can use this tool, not just at the start, but something that in the future for large studies can use other ways of engagement beyond like a toll-free number or an email. Are there ways of passing information that will allow action? As I mentioned, the pre-filled locating here, just locating. I'll skip to the quick summary here, and that is we have a list sample component of the Survey of Consumer Finances, and the benefit there is we have the names of participants plus a sampled address, and that allows us to target our mailings. We've done some address matching before in previous rounds of the SCF, but for the purposes of steering mailing and making sure that, particularly with the lower wealth stratum that we field alongside the area probability sample, it was an important tool in being sure that when we put interviewers on the ground or made contact through mailings, that we had a good understanding of where folks were. And the key takeaway here, I'll just give you a quick update of this table, that, the address confirmation was a useful tool in terms of thinking about where to direct interviewer attention across these two different stratum, which they have different characteristics, different makeup of the participants demographically. The completion rate for those addresses, we could confirm where folks were. Completion rates were very similar across the two. It's in these new address updates where we see some differences, that it's worth really thinking more strategically about how to utilize some of this information in developing mailing strategies, developing outreach strategies that help us consider how do we direct limited interviewer activity in engaging our sample. So here's the last update, just something to share from our 2022 experience that I want to leave you all with. As I mentioned, with the Delta variant still spreading at the time of recruiting and the time of data collection launch, we really did look for alternatives to allow us to use phone as a primary mechanism for initial contact, which was completely new for SCF. A lot of face-to-face long-standing surveys. This was a similar pivot that many studies had to consider. In order to do that, we matched our selected household sample with electronic database matches to identify phone numbers. We found phone matches with some confidence of quality for roughly half of the sample addresses. We had to train interviewers in what phone approach, what that would look like, including adapting our screening protocols to ensure that they're verifying the address. If an interviewer is not there on the doorstep, it's hard to make sure that we are talking with a person that really is residing at that location. So a screening protocol enhancements were really important. And then we wanted to look at pair data to understand, like, what were we getting for those phone attempts throughout the course of data collection. We had over 42,000 recorded phone attempts by interviewers throughout the course of the data collection period, versus about 38,000 face-to-face contact attempts. Now, this isn't to say that those are big numbers, big differences. We've had recently, over the past several rounds, actually, and not recently, but we've been building up the use of phone follow-up. But it's the initial contacts and when we're really able to speak with somebody that we were interested in understanding. So speaking with individuals at a household, what do we know? And on this chart here on the side, you'll see some bar charts. These are roughly associated with quarters of data collection. We divide our data collection windows into quarters of about roughly 9 to 10 weeks across the course of the calendar year. And we had OT here as our overtime as we were tracing down final contacts and working to finalize the survey in early 2023. So what we saw here is we actually were pretty successful initially at connecting with individuals at households by telephone. In fact, we had more opportunities, more contact opportunities where we talked with folks by phone than we did in person. And that is reflective of what we thought at that time in terms of instructing interviewer activity, the ramp up of interviewers coming into the field. And also, as we look at the trends over time, definitely as the summer came, Delta waned, we trained up our interviewer workforce and could return them to more normal face-to-face activities in locations where we had interviewers staffed. We did see an increase in a more traditional face-to-face interaction with respondents. Now, the other interesting point here is what happens in the first time. So if we're starting out of the gate and we're connecting with individuals, we really do, as part of our contacting strategy on the SCF, rely on interviewers to make contact with somebody at a household as quickly as possible when they're in the field in order to, A, resolve as many cases as complete as we can, but also look for ways to gain cooperation, provide additional information about the survey, answer questions, and really start to build a relationship between the interviewer and the respondent that ensures the respondent can make informed decisions about participation, but also that we're set up to succeed in terms of reaching targets and completing interviews. So what we see here, not surprising, is it's flipped in a way. We were able to connect with folks by phone the first time that we spoke with somebody, but it's that in-person outreach that still matters. And you can see that in that first quarter, when interviewers began mobilizing and knocking on doors, it was this in-person visit that initial in-person visit that really resonated and continued to propel us forward in gaining cooperation and making appointments. So what does that mean in terms of results? And this is just a very basic thinking about the mode of contact the first time we spoke with somebody. What did that do in terms of overall completes? Now, there's much more complex analysis that needs to be done, but just to do a basic descriptive understanding. Overall, when we first met with somebody by phone, we ended up completing 300 or so interviews. Roughly 30% of those initial contacts by phone resulted in completes. And overall, in person does slightly better, not unexpectedly, but as you can see, we have more, just over 800 completes for about 30, call it over a third, just over a third of the contacts first facilitated, those conversations first facilitated in person, still matter. And even more so in the early parts of the first 9-10 weeks of data collection, you can see even greater impact. Yes, phone made a difference. We did better when we connect with folks by phone in those early days. We were still just shy of 40% to complete, but in person, we're up over close to 44%. So that those early contacts matter. And even though phone shows some signs of being successful, it's the in-person traditional approaches that still really seem to shine in terms of our success in converting and completing interviews. So as we think about combining approaches here, what does this mean for us longer term on larger field studies? Those initial in-person interactions do appear to continue to yield those positive results. Initially speaking to participants on phone, though, don't seem to have any dramatic, at least from that initial view, a dramatic impact in terms of overall outcomes. We're still completing cases at similar rates, just not quite as high. And then, I think there's a greater need to think about mode within the context of the whole. What are the different types of observations, the different types of responsive approaches that we're putting into place, all of the interventions, incentive increases, the use of specialized interviewers, addressing obstacles, mode approach, and speaking with potential participants in the field. This is just but one of a full a suite of different tools that we use to really meet our respondents and invite them to participate. So we want to think about that and building more effective design models to track our operations moving forward. So with that, I didn't get to touch the pre-filled locating like quite as much as I want to. I want to make sure I leave Katie some time here. You know, web-based contact forms and other similar tools, you know, this could be text-based, it could be, I know folks are trying all sorts of different new innovations to attract and invite participants to find out more about the study and engage with our research teams. This also goes hand in hand with the need for greater specialization within our workforce to ensure that our engagement with these interested parties is responsive and timely. On the pre-filled locating, address matching has value. I'm happy to talk offline with folks who want to learn more about this. Mode of contact and speaking with potential participants, as I just said, you know, the in-person outreach still is valuable and important. We're lucky enough to be able to pivot throughout the summer in particular towards a more traditional in-person favored approach, but phone works well. And there's something we can learn from what we had to do out of necessity in 2022 that might benefit us moving forward into the future. So with that, I think, Kathy, I'll hand it back over to you.
Thanks, Micah. We have one more speaker, Katie Archambault. She's Senior Data Scientist in the Methodology and Quantitative Science, Social Sciences Department at NORC. In her 18 years at NORC, Katie's worked in a broad range of studies, such as the Survey of Consumer Finances, the General Social Survey, the Medicare Current Beneficiary Survey, and Women's Health Surveys. She's an active member of the GIS team at NORC, as well as regularly contributing to sampling, monitoring, and data delivery activities. Thanks, Katie. Take it away.
Great. Well, let's close out today with this final talk of the session, and it is called Sharpening Our Tools, the Use of Our Indicators in a Challenging Context for the 2022 Survey of Consumer Finances. And I would like to thank my co-authors, all listed below. So we'll first talk a little bit about our indicator background. A few years ago, we did present at this same conference on our indicators. And so now we are excited to come back and tell you more of our results from the latest round of the SCF. What are our indicators? This stands for Representativity Indicators. And you can see now why we like to call them our indicators, because that is quite the mouthful. They are an integral part of adaptive survey design, which is becoming ever more popular as we're trying to increase our response rates and just make quick adjustments in the field period. The R indicators are essentially output from a logistic regression equation. We have independent variables, and these are predicting which cases are completed. And then our dependent variable is whether or not the interview is completed. There are 3 levels of R indicators. Up at the top, you'll see we have our overall sample R indicator, and this will be a value between 0 and 1. Essentially, it's an overall indicator of the sample's representativeness. It's answering how well does our collected sample reflect the drawn sample or the underlying population. For this overall sample indicator, we like to see a value as close to 1 as possible. Then we have our middle category, and that's our unconditional variable R indicator. So an example of this would be something like age. We would have a value between 0 and 0.5. And then we're going to kind of flip the scale here. And in this case, 0 would indicate our sample with respect to our associated variable has perfect representation. All that to say, we want a smaller value for the unconditional variable R indicator. Anytime we have a larger value, that indicates more differences between our sample and our completes. One thing to note about that unconditional variable R indicator is that we don't know what direction the difference is in. So if we have a value that is closer to 0.5, we don't know if we're getting people who are older or younger. We don't know the direction of the association. We just know that 0 would indicate that there's better representation. Then finally, we have our unconditional category, our indicator. And this is where we can kind of drill down and get more detail about who we think we are missing and who would give us better representation. This is now a value between 0 and plus or minus 0.5. And this is finally where we learn whether a category is over or underrepresented in the completed interviews. 0 remains our perfect representation, what we're going for here, but closer to 0 is good. Further means that we're straying a little bit from that representation. For an example, we could say there's a category of age over 65 years. The closer we get to a positive 0.5 would mean this population or this group of age over 65 years, we believe them to be overrepresented. The closer we get to negative 0.5, we would believe this group to be underrepresented. So this is probably one of the more helpful R indicator categories because it actually gives us the direction that we would like to try to correct. So in the SCF 2022, our current R indicator work, I'm going to skip over this general slide about the SCF, but I do want to point out that this is a dual frame sample. I know that was mentioned earlier, but the work that we're doing on R indicators right now is limited to the area probability sample. So the list sample is not included in our R indicators work yet. To build the model here, we first have to identify key statistics that we're going to use for the model. An important thing to note is we have to use covariables that are available prior to the start of data collection. So nothing that we collect during the field period can be pulled into the models. Everything has to be available prior to data collection. And then once we choose those variables, we keep them consistent throughout the field period. For the SCF, we ended up choosing about, I think it was 20 or so, 20 total block group variables from the American Community Survey. Because we have to use variables that are available to us outside of collecting our data, we are limited in what we can use. And so that's where the census comes in as kind of a perfect answer for us to select variables that we can use here. Some examples, we use things like owner-occupied rate, ages, home value, education, language. Those are some of the variables we put in our model. And then we also had a few areas of SCF paradata that we used because we oversampled this round. We had variables about likelihood of Asian resident, Black or Hispanic resident. We put those in our model, as well as whether or not the sample line was a multi-unit building. Our strategy going into 2022, number one, was to work collaboratively with our field staff. We knew that any attempts we were going to make to do this adaptive survey design during the field period, we had to have buy-in from every aspect of our team. And probably the most important part of that team was the field staff. They would be implementing any changes and carrying them out, so we needed to work collaboratively. And once we had their buy-in, we added in using propensity scores that we got from our R indicators, and we identified our most underrepresented cases from our cases that we hadn't yet completed. Together, we used this to identify 10 to 15% of our not yet completed cases with our lowest propensity scores, and then we worked with our interviewers to increase effort for these cases. How do we increase our effort? First, just by building this list and distributing it to our interviewers. We called them higher priority cases because we didn't want high and low priority because there is no low priority case. Every case is valuable, every case is important. So we had kind of our normal priority cases and then our higher priority cases. For those higher priority, we sent additional mailings, we escalated post incentives, And we also made use of maps that could show pending cases by priority. Our field interviewers travel, plan trips. So as they were organizing their routines, their travel, they were able to use these maps to kind of focus their efforts on places that may be most productive and the best places to go to get us a representative group of respondents. During data collection, we did end up having 2 interventions. In October, we flagged about 650 cases as higher priority. So this is about the bottom 10% of our propensity scores. And then later, in January, we replaced those cases with a new set of cases. So this is important because we didn't add, but we replaced the full set, and there were about 800 new cases that we were now calling higher priority. I think of interest and importance is that less than 50% overlap between the 2 interventions. I think that was a little surprising to us, and I will touch on that a little bit later. Here you can see what a great job our field did of completing these cases that we deemed to be higher priority. The top table shows how our October pending cases, how they finalized, and then our January cases are in the bottom table. And you can see in both instances, those cases we deemed to be higher priority and sent out to the field staff and asked them to really prioritize. They completed at higher rates. So for the October cases, there's about a 4 percentage points higher for those cases than there were for the rest of the cases. And in the January cases, we completed the higher priority cases about 5 percentage points more. This will get into a little bit more nitty gritty of the model. So I don't want you to get lost in the detail here. I think it's just important, if you're going to look at one thing, look at the color. Green means we moved the needle in a good direction. We moved towards greater representativeness among our responding population. And that is really the goal of what we're going for. The top line there, the concordance score, I'm going to give a quick definition of that to make that clear. The concordance score is the percentage of completes and incompleted cases that are predicted correctly by our model. So perfect representativeness is a concordance score of 50%. And that means the model is purely guessing, which is what we want. We want to get a number in that concordance score as close to 50% as possible. And we moved in that direction. As you can see here, we started our October model at 56.2% and moved it down to 54.7%, which is closer to 50%. And then our partial R scores at the bottom, most of those moved in a good direction, so they got closer to 0. And that is what we wanted to see there. And the same really held true for our January intervention. You can see down at the bottom, some of those partial R scores, they became not significant for our final model. So once again, we're accomplishing what we had hoped, which is getting better representativeness with the population responding to the survey. So some final results of our SCF 2022, our indicator interventions. We were very pleased that our interventions did seem to improve representativeness. I talked about that concordance score, where 50% is our ideal here. In October, we could predict completion status for 56.2% of cases, and that dropped to 54.8% in our final best model. If you put those numbers together and do a little bit of math, identifying those higher priority AP cases removed about 22.6% of our biases. And we were quite pleased with that number, and we're just very thankful to our field staff for following through so diligently in pursuing these cases. Then before I did say we had less than 50% overlap between our October and January cases. And one of our takeaways here is that we believe we probably only needed one intervention. In fact, we think our field interviewers did so well that it kind of, by the time we got to January and created a whole new set of cases and put them out in the field. You can see the second to the bottom bullet. We replaced some of our higher priority cases from October, and some of the variables from our earlier model tried to return. This isn't a terrible thing, but it just shows how well our first intervention worked. And it says maybe we didn't need the 2 interventions, and perhaps a better strategy would be to add cases and not completely replace them. Not only did the math kind of replace them in a sense, but there was a little bit of a challenge in explaining the shift to the field. We've emphasized one set of cases so strongly, and then a few months later we say, forget about that. We have a new set of cases, and that's a little bit of confusing messaging. So we want to be clear in the future and think about maybe a better way to communicate that and to add cases instead of replace them. So what are our future plans? In future studies, we want to continue collaborating with our field staff. We think that was a key to success here, something we want to carry forward in the future. We also want to see how we can extend our application of the R indicators to the list sample. Like I mentioned, we're only doing this with area probability for the 2022 SCF. We think studies that have list sample could also benefit from our indicators, and we want to pursue that, as well as identifying additional variables prior to data collection that we can use in our models. Because we have to identify these variables before data collection, we are limited, but we think, with so much big data, there's just a lot out there, and we want to see what other things we can find that we can put into our model and find useful in helping us with our R indicators. And with that, I think we have come in with just a little bit of time for 1 or 2 questions. So Kathy, I'll hand it back to you.
Thanks. Thanks, Katie. Geez, we took up almost the whole time in our presentations. For those of you that have a question, let's see, you can raise your hand, but now let's see, how do I get to pick the names of everybody in the audience?
I could keep an eye on it. Right now, we have no raised hands at this time.
Okay. I could ask a couple of questions. Katie, maybe I could start with you. So you talked about plans for future R indicators, for future studies using our indicators. One of the things you mentioned was maximizing collaboration with the field staff. Could you talk a little bit about that? How would you do that?
Sure. So I think one of the biggest ways to do that is not to bring our interviewers in when we want to do the interventions, but to bring them in before data collection even starts. And so creating a team of field staff and office staff to come together before we even start our first interview to think together, to make sure that everybody is buying into this, because the field has so many competing priorities during data collection. And it's really important to give them a good understanding of why this is important, and then to meet regularly, and just to kind of share our successes and, celebrate together too. I think that's important.
Great. Thanks a lot, Katie. Callie and Shannon, I have a question for you. With the in-person training, you have the opportunity to observe the learning environment and witness interviewers' engagement. How do you do that? How do you observe engagement with the interviewers when they're fully remote?
We have different sort of technology things that we like to use. We will pop a question into a chat, use a whiteboard, use a poll. We still like to break into breakout rooms and keep those breakout rooms as small as possible so that the leaders can have a chance to interact with everyone being trained and the trainees can all have a chance to interact with each other. And for people that we don't really see interacting in either the breakout rooms or on these little technology segments, we reach out to them via email or phone or, some other means to see if there's a reason they're not participating and to draw them in to connect them.
Yep, that's great. Thanks, Shannon. Mike, I have a question for you. The web-based contact form provided an early boost to production. Do you have any plans for, I don't know, expanding the use of the web form in some way or changing it, enhancing it in the future?
I think one of the things that would be useful is to do some more deliberate experimentation so we can understand its uptake and use. As I alluded to briefly, I think there's a lot of potential to use similar types of tools in the process of collecting data. So if there are leave behinds, ways of encouraging potential participants to reach out to us directly across the field period, not just at the initial advance mailing period, but using this tool to help provide another avenue for potential participants who are curious, want to know more about the study, to engage with our study teams.
Great. Thanks, Micah. And Heather, I have a question for you. I know we're into overtime, but it sounds like you're recommending that we expand Carrie. We, as you know, had just a few minutes of Carrie recording. And if you want to sort of explore this, look at cultural sensitivity, it seems to me we'd have to have a more robust recording. Of course, the interviewers don't know where we start and stop the recording. And I suppose I've always been concerned that since the SCF collects such very sensitive data, that this might be a reason for respondents to refuse to participate. Anyway, I don't know if you've thought about any of those things and what we do.
I think, we'd have to really think it through. So I know one issue is the microphones and if they can really capture the interactions very well between respondents and interviewers. So that's something we'd have to think of. The extra manpower that it takes, that's another thing. And then I think you're right, we'd have to be really smart about how we target what we record. Maybe things that don't include dollar figures like the household roster or screening procedures. Or even the questions that we have that have to do with financial literacy that don't really collect people's personal information, but more their opinions on things. That might be an approach.
Oh, you have thought about this. That's great.
Yeah.
Anthony, I don't know if there's any question or any hands raised. We are way into overtime now. It's the dinner hour here in the East Coast.
No hands raised anyway.
All right. Well, boy, we really appreciate it. There's still 24 participants. That's great. Thanks for hanging in there and listening to our presentations. Heather, if you could put your email address in the chat as well, just in case, or not, Heather, you already did that. Katie, if you could put your email address in the chat so folks could reach out to you if they have any questions after the session. Anyway, thanks everybody for participating, joining our presentation this afternoon, and we hope to see. Oh, Pamela, thank you. We hope to see you all again next year. Thanks very much. Oh, look at that.
Thanks, everyone.
Bye, everybody.